that launched people like 2 weeks ago. Is that crazy or what? Okay, SpaceX's cast isn't up yet. I'm just going to go put on another pot of coffee, and I will be right back here.
Discovery, go at throttle up.
Hey, Urbanus. Keep up the good work. Thank you. Fresh Pots, Rotor, 20-month resub. Glad I could catch this launch. Yep. And in case anybody's wondering, the Rocket Lab launch got postponed. It's on Sunday. So that's nice. That's good. Yeah, Sunday. That's... I don't even want to blow my brains out. That's good.
Stage 2 LOX load has started.
Alrighty. Looks like they haven't started the cast yet. Unless I give it a quick refresherino. Nope. Why is Mission Control so empty? Everybody's working, man. Everybody's at their desks. Is this the fastest turnaround of a booster? I think so, dude. Yeah. This is up there. Anyway. Blue. Once again, Blue. Blue Mary Doc, thank you very much, dude. Really appreciate it, man. Trying to keep it real as best as I can. You know what I'm saying? End of stream? No. Aliox, we have a rocket launch. We're just waiting for the stream to pop up. Yep, SpaceX is going to launch a rocket here. Still waiting for the 24-hour recycle. NSF is up. Yeah, there we go.
You asked how often they test, and they test so often that a test was occurring when we started this stream. And I was like, well, seeing to put it on the stream, so that's what you saw there.
Yeah, so this is the NSF thing. They got their brand new McGregor live cameras going, and then there's the rocket right there. Also, this is the quickest pad. The quickest pad. I know that pad 40 was turned around in 8 days. Yeah, they turned around pad 40 in 8 days in like 2015, because they had to clamp down because 39A was not ready yet, so they had to launch a lot from 40 from the Cape. Yeah, I think that this is the shortest reflight time of a booster. I'm pretty dang sure. How many pots does EJ go through a day? Glitrub, this is a huge mug that's like, I don't know, like 3 cups or 4 cups or something. And I usually drink 2 of these a day. So I'm at like 6 cups of coffee. It's better than 6 Red Bulls. Cast is live. Okay, cool. Let's flip back over there. What cargo fly in space? Starlink, Ilya. Это Starlink. Starlink? I don't know how you'd say Starlink in Russian, to be honest with you. Это Starlink. Don't you get the jitters? No, not at all, Pop. Pop, I'm 6'4", 250 pounds. It's gonna take a lot of caffeine to get me going. Zvezdaya? What's that second word? I don't know how to say that second word. Signal. How do you say that?
Signal.
Signal. Yep, okay. Got it. What about the first word, Ilya? Zvezdani, yeah. Zvezdani signal, да. So, Ilya, это Zvezdani signal. Eh? SpaceX. Meme Lord. Mr. Broomstick. Coffee gives you the poops, can't drink it, that's why I drink energy shots. Yeah, you know what that might give you the poops, but you know what gives you the times? Swearing in my chatted mana. Riggedy wrecked! But yes, I know what you mean.
Ice launch checkdown countdown net. Pad is clear.
Alright, here we go.
9,
Starlink.
8,
Launch auto sequence
7,
has started.
6, 5, 4, 3, 2, 1.
Go for launch.
Oh man, that's gonna be a good day when that does that again. Yeah.
Stage separation confirmed. Dragon separation confirmed.
Gonna need a montage.
Stage 1 is transonic. Landing legs have deployed. And Falcon 9 has landed.
Hello, and
I do,
welcome to
Addiction,
our
yeah.
10th Starlink launch of the year and 44th Starlink mission overall. My name is Jesse Anderson. I'm a production and engineering manager here at SpaceX, and I'll be your host today as we follow Falcon 9's launch from Florida's Cape Canaveral Space Force Station, Space Launch Complex 40, about 8 minutes from now. Starlink is a satellite internet constellation designed and manufactured by SpaceX. It provides high-speed, low-latency internet to people living in remote and rural locations around the globe. Starlink is currently servicing 34 markets, and we recently went live in Latvia, with more markets being added soon. Our launch today will be taking 53 Starlink satellites into low Earth orbit, or also referred to as LEO.
Naro Nips, I have a question. I'm at Cocoa Beach, just south of the launch sites. Will I be able to see the rocket? yeah, you'll see it, man. Cocoa Beach? Just look north, probably about 10 to 15 seconds after launch. If it's clear, and it looks pretty clear down there today, you'll see it. Oh yeah, it'll look like a candle. Seriously, it'll just look like a candle flame, just upside down, going up into space. And you'll probably hear it too if you're in Cocoa. You'll hear it. Oh yeah.
The vehicle that you see on your screen is our Falcon 9 rocket, and the Starlink satellites are housed at the very top of the rocket in a structure known as the fairing.
We were just working on one of those.
And there you can see the fairing on your screen. The job of the fairing is to protect the Starlink satellites until we reach the vacuum of space.
You won't be able to see it land, I don't think. That's going to be over the horizon. You might be able to see the landing burn, though. Maybe. It really kind of depends. I think the Starlink is going on the northeast trajectory. If it's going on the northeast trajectory, it's going to be a little harder to see. But anyway, I want to listen to Jesse.
If you're familiar with SpaceX, you know that reusability is one of our top priorities, as it is key to reducing the cost of space access for all of us. Falcon 9 is the only orbital class rocket in the world capable of reuse, which means that it's the only rocket that can boost its payload to orbit and then come back down to Earth to be flown again.
Just slam dunk on the
part
space
of the rocket
shuttle.
That's responsible for powering these repeat trips to space is called the first stage. And
There you go, Nips. Yeah, you're in for a
that you
treat.
see on your screen.
Actually, Nips, you're in this picture,
The
by
dark
the way.
soot
You're over
that
there.
you might be able to see
True
around
story.
the base of the
Jetty
vehicle
Park is over there,
are
and
remnants
you
from
can-
its previous launches.
And you can see
This
Port
particular booster
Canaveral
has
way
supported 5
down there.
previous missions. GPS
It's about,
space,
I don't know, 20 miles, 30 miles from you. You're
GPS
down
3
there. See
space
the buildings?
vehicles
That's the
4 and
buildings
5,
at Cocoa Beach. They're
Inspiration
way
4,
on the
a
horizon out
Starlink
there, though.
mission, and most recently, AX-1 or Axiom-1, which just launched 3 weeks ago.
Crazy.
In fact, the booster that you see on your screen had the fastest turnaround time to date. The AX-1 mission launched on April 8th, so it only took the teams 9 days to refurbish, and today marks 21 days to get it back to the launch pad to support today's mission. That's a great milestone for our teams, as it brings us one step closer to providing fast and reliable access to space
9-day refurbishment?
for all. Now, the number
9-day
9 in
refurbishment.
Falcon 9 references the 9 engines on the first stage. There's actually 10 engines on the vehicle overall. The 10th engine powers the second stage, which is the portion of the rocket that you see on your screen at the very top of the rocket below the fairing. Now, while the first stage powers us out of Earth's atmosphere and into space, the second stage takes the satellites to their targeted drop-off orbit. After the first and second stages separate, the second stage will ignite its single Merlin vacuum engine and carry our satellites to low Earth orbit. Though very similar to the Merlin 1D engines on the first stage, the Merlin vacuum engine has a larger nozzle that allows the second stage to perform better in the...
Tank suppressing for strong back retract.
Okie dokie.
Allows
Tank
the,
pressurization is happening here.
MVAC engine to perform better in the vacuum of space. Now,
Rocket
following
Lab got
separation
postponed,
of the
alleviate.
second stage, we will be attempting to recover the first stage for a 6th time on our drone ship. Just read the instructions, and you can see that there live on your screen.
has started.
Okay, they're going to
And
open
if
up the claws on
successful,
the
it will
strong
mark
back
the
here.
117th recovery of a Falcon 9 first stage. Now, we are coming up upon the TE retraction, and to do
Thanks.
so, the
26
clamp
month resub.
arms need to open, and you can see on your screen those clamp arms just below the fairing are opening up.
Strong back will
Once
move
they're
back
fully
into
open,
the 80,
the
89
transporter
degree
rector will
position.
start to move slightly away from the vehicle and clear its way for liftoff.
Yeah, you should see the gray
If
structure
you've been
right here just
following
move-
along, you know that
move
we've had a
that way little
pretty
bit.
busy week here at SpaceX.
Yep, there it goes.
On Sunday, the first ever private astronaut mission to the International Space Station undocked from the floating laboratory and safely splashed down the following day in the Atlantic Ocean. After 17 days in space,
Mikey.
here you can see the Axiom astronauts taking their first breaths of fresh air in more than 2 weeks. Here you can see Commander Michael Lopez Alegria, pilot Larry Connor, and mission specialist Mark Pathy and Eitan Stibba.
Stibba.
Then early Wednesday morning, SpaceX launched Crew
was fun.
4 carrying NASA
That
astronauts
was a
Kjell
good
Lindgren,
time.
Bob Hines, Jessica Watkins, and ESA astronaut Samantha Cristoforetti to the International Space Station. It took the crew about 16 hours after liftoff to reach their destination.
Stage 1 LOX load is complete.
And along the way, they took a
Mint.
moment to have some fun and give us a little tour around the Dragon spacecraft. And we're not done yet. With Crew 4's arrival to station, Crew 3 is now preparing to return back to Earth after their long-duration stay aboard the International Space Station. So
That's
stay
happening.
tuned for more on that. And this has also been a great week for anyone who's ever had a bad Wi-Fi experience on a plane, as Starlink is now coming to air travel.
Yep. This is
JSX,
huge.
a regional air carrier in the continental United States, and Hawaiian Airlines have both selected Starlink as their in-flight internet provider. And both airlines will make Starlink service available
That's
to
nuts.
every passenger without complicated login or payment screens, so that when customers get on the plane, the internet just works. So that's
don't
very
say that.
exciting.
It just works.
But with just a couple minutes left to go, Falcon 9 is moving into the final stages of the countdown. We already heard LOX
just
load
works.
complete on the first stage. We are awaiting completion of LOX load on the second stage here.
Blue shorts. Just doesn't even need to stay in guns. It just stay.
Stage 2
Todd,
LOX
just
load is
stay
complete.
Stay what you're doing. Just-
Great news,
just
that's
go
that
over
call
there.
out. What that means is now prop load is complete on Falcon 9
Okay.
and ready.
I'm just gonna fast forward real quick. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Just make sure we get caught up with the cast. I know sometimes latency can introduce a little bit of delay that won't keep you like completely live. But there's the TE purge down. They're pumping helium or nitrogen up the second stage fill line. Oh, geez, she's moving. Whoa, she's moving. Why is she moving? Okay, here we go. 20 seconds. It's a little windy. Did you see it moving? And people say real rockets don't
15
wobble
seconds.
around like they do in KSP.
T-minus 10, 9, 8, 7,
Sound suppressor is on. Here we go.
5, 4, 3, 2, 1. Ignition. Lift off.
Okay, she's flying. That looked good. I really wish the stream didn't pause for a second when... really wish it didn't pause for a second at T-1. I'm like, uh-oh. Everything looked good there, guys.
M1D chamber pressure is nominal.
Alright, cool. Yeah, liftoff looked good. Ignition looked good. We got the green flash from the pyrophoric ignition fluid. There's igniter fluid in the first stage on Falcon 9.
Falcon 9 has successfully
And it leaves a
lifted
green
off
flash
from
when the
Space
engines
Launch
start.
Complex
You'll see it
40,
again when
carrying
the second
our
stage flies.
53 Starlink satellites. Now, although at liftoff gravity is pulling the vehicle straight down, as we ascend, we tilt the engines.
Power and telemetry nominal.
And tilting those
It's a little
engines
laggy.
is
The
called
simulation's
gimbaling.
kinda-
That turns the rocket horizontally, and you can kind of see that there on your screen.
Oh, what
So
a
we are
track.
still going up, but we're also heading horizontally away from the launch pad.
Oh!
And that is what we call a gravity turn. And we
Supersonic.
are coming up on max Q here in a few seconds.
Ooh, that's I like what I'm seeing here.
Max Q.
And there's that call out that we've just passed through max Q. Now that's the largest structural load that the vehicle sees on ascent, and we have passed through it. So next up will be a series of events. First will be MECO, or
Shut
main
up, Chief. I
engine
can do it if I
cutoff,
want
and that's
to.
where all 9 of the Merlin engines will shut down. And that slows the vehicle down in preparation for the second milestone, which
Start
is
of MVAC engine chill.
Okay, they're priming the second stage
Second.
engine, filling it with fuel.
milestone will be stage separation. That's where the first and second stage separate from each other. First stage will start to make its way back to
Max
Earth,
Coggers.
and the second stage will continue on its journey with
Vehicle is following a nominal trajectory.
GNC reports nominal
with
trajectory on the Falcon
SES-1,
9.
or second stage engine startup 1. And that's where the single Merlin vacuum engine will light up and propel the second stage along with the Starlink satellites to orbit. We've got some awesome views watching Falcon 9 on ascent.
Most
We're just about
Starlink
15
trajectories
seconds
do
away
that, yeah,
from
to
those
squeeze a
three
little bit more
events.
performance
MECO,
out of that
stage
first stage.
separation, and SES-1. Just about 10 seconds or so
should see
after
it.
SES-1, we should also see the fairing halves jettison from the second stage.
You should see a big puff of smoke here come from the first stage. That's the purge out system. They hit it with helium
Main engine cut off.
to get the gaseous locks out of the engines.
Stage separation confirmed.
Separation looks good. Watch for the green flash.
And back ignition.
There it is. Perfect. Good staging, good ignition. That booster just flew into space 3 weeks ago. Stand by for fairing separation. Okay, saying good fairing sep. Everything looks real
And
good here.
some incredible
Real
views
good.
there. We just had MECO's stage
There
separation.
goes the fairing in the background.
You can see
there.
those fairing halves on your right-hand screen
Both
falling
vehicles
back
are
to
following
Earth.
nominal trajectories.
And got some nominal call-outs. The MVAC engine lit up on the second stage. The first stage grid fins have deployed. So on your left-hand screen, you're looking at a view from the first stage. On your right-hand screen, you're looking at
My
a view
boat
of the
deployed.
MVAC engine on the second stage.
Okay, so the first stage basically
While
just
that
going to
second
coast till it
stage
gets
is
to the
doing
entry
its
burn
job,
here.
that first stage is coming back home to Earth, and it'll execute 2 burns to get back home. First is the entry burn, and that's where 3
my
of the
boat.
9 M1D engines reignite, and that helps to slow the stage down as it's entering back into the denser part of the Earth's atmosphere. Then the atmosphere actually helps to scrub a lot of the velocity of the vehicle until the second and final burn, which is the landing burn. That's a single engine burn that brings the vehicle speed down
Yeah.
rapidly in order to touch down on the drone ship.
Acquisition of signal, Bermuda.
And again, today we will be attempting to land on Just Read the Instructions. And each one of these M1D engines is about 190,000 pounds of thrust. So we do only use one engine
900 kilonewtons
for that final
for the metric
landing
people.
burn to touch down on our drone ship. And the drone ship, just for size, is about equivalent to
Both vehicles are following nominal trajectories.
Guidance officer is saying that the first and second stage are going exactly where they are planned. In a second here, that the second stage here will go into what's called a closed loop or inertial guidance, basically where it will fall out of signal for the ground stations here until it reaches another one. And in the meantime, what it's going to use is the accelerometers on board, or the inertial measuring units on board, to figure out where it is, to figure out its trajectory. It doesn't need an external source. That's what closed loop guidance is. We should hear the call here in a moment.
right before the vehicle touches down.
I think SpaceX calls it terminal guidance.
Got some great views here. Again, on your left-hand screen is a view looking aft.
pretty good, Admina.
Now looking forward of the first stage.
Look at all the soot.
And on your right-hand screen.
It's interesting to note all the soot inside of the inner stage right there, and that's from the exhaust. That's from the second stage engine outgassing into the inner stage. That's what all that crap is on the inside of it. It's pretty weird, right? Like things been used before. This thing was flying on the 9th, on April 8th. It was 20 days ago. Isn't that crazy?
White puffs there.
So yeah, Jesse's talking about the attitude control systems, the ACS. That's compressed nitrogen gas that gets shot out. If you see like what looks like ice and stuff kind of coming off the booster up here, like that, right there, that is the outgassing from that nitrogen booster. When nitrogen at high pressure gets outgassed and it goes from super high pressure to extremely low pressure, the vacuum, like that, it solidifies. Yes, solid nitrogen can only exist near 0 K. That's what all those flakes are coming off there. Now, okay, here's my favorite part. Here it is. Here it comes, fellas. See that? The entry burn right here. This first stage is coming down, going 7,000 kilometers an hour right now, and it's slowing down because the engines are firing. That's live telemetry right there. But 7,000 kilometers an hour is pretty freaking fast. You'd usually need a heat shield coming in that quick, but Falcon 9 firing its engines like that actually pushes the reentry heating away from the vehicle. It's called supersonic retropropulsion, and it's an idea that NASA pioneered for landing payloads on Mars. Yeah, the engine's firing is not only slowing the booster down, but it's the heat shield. The rocket's exhaust is the heat shield. It's cool enough to be able to give a good thermal medium between the reentry heat and the booster, which obviously doesn't want to melt. He said the thing! And then, now that it's through, you're going to start, if they show it, you're going to see the grid fins start wiggling around as it starts to catch the atmosphere
here of
again.
the second stage.
He said
I
it!
mentioned that soot earlier on the first stage. As you saw,
Watch the grid fins start wiggling. Stage 1 is in the transonic,
actually enters back into
transonic regime. Oh, look at that. You're getting some crazy pressure changes from the grid fins. See, that's what that is going on right there. Look at the gases are trying to condense coming off the grid fin because of low pressure, because of the drag. That's like visually what drag looks like. Look at, oh man, those grid fins are really working. See how much they're wiggling around? The pressure is going up real quick. Okay, there's the landing burn. We got no clouds out there. You can see the drone ship. There it is. Grid fins are going to steer it in, and then once this thing gets under like 120 miles an hour, that's when the grid fins are really kind of not doing much. They'll lock into position, and then the engine's kind of steering it. There they go. They locked. Landing legs deployed. They just got there's the terminal guidance call for the second stage. 1062 is back down on the ground. Easy peasy. Well, you get what I'm trying to say. Now what you'll see here is they'll vent down the stages. They'll bring the tanks down from flight pressure, and they'll purge out all the engines here. They'll purge out all the engines because they don't want any oxygen getting stuck inside of the motors, the liquid oxygen. It's corrosive, so they purge out the engines. They pump helium into them. Okay, stand by for second stage engine cutoff. You see the purge out system on the second stage happening right there. They're going to do the same thing to that second stage engine, so, well, the engine doesn't rust. Seriously, you're using liquid oxygen as a commodity here, as your oxidizer. Oxygen makes things oxidize. I know. Funny story. Funny you should mention that, chat. But see, there's the purge out systems. See it right there? Pretty cool, huh? Dude, that is dead center. Look at how, dude, the water out there is calm as heck, man. There's nothing. What a landing, dude. Yeah, I know, Tessa. That was about as smooth as it gets. That is dead center.
The Federal Aviation Administration.
Damn, man. That's so cool. That's so freaking cool.
And of course, thank you to
Oh
all of
my
our viewers
goodness.
and all of our Starlink customers using our service at this time. Keep an eye out on our social channels for the latest SpaceX news, and we'll see you next time.
Oh, they're stopping before deployment. Jeez. Can I just if you'll excuse me for a second. We could see the drone ship from up here. Let me just replay this right here. 2 times in 1 month on 1062. Man, look at those grid fins shaking around. This is it coming back down into the atmosphere. I mean, okay, so the crazy part about this is that this is, let's see, how high up are they right now? 4.1 kilometers, so it's 4,000 meters, so we're at about 10,000 feet here, give or take. It's a little above 10,000 feet. I mean, this thing goes 10,000 feet down to the surface real fast. So you're starting to really get into the thicker parts of the atmosphere. The pressure's starting to come back. And it comes back real quick. Watch the air getting compressed up against the grid fins right here.
Discovery, go at throttle up.
Oh, that was actually before this. They're doing the landing burns going on right there. Oh my goodness. Dude. What the frick? Warlock. Considering 1 to 2 days for the ship to get back cuts into the turnaround time. Yeah, Salty, I know. Looks like there was a little bit of coking going on up there. Hold on, was that on there before that? I'm trying to look up here. Nope. So if you look at the drone ship right here, they sprayed the drone ship down with water. that the water actually film cools the deck of the drone ship. Now, I know if you're wondering why the rocket engine doesn't melt the surface of the drone ship, well, one, it's only on for a second. Two, even if a rocket engine's only on for a second, that's still enough to melt a hole right through this thing. You'd burn a hole right through it real quick, like a big acetylene torch. I mean, that's basically what the rocket is. It's close to an acetylene torch. It's just an acetylene torch shooting into a funnel that accelerates the gas. It's similar idea, so like a big blowtorch, right? It's a blowtorch, but under pressure. So what they do is they spray the water down on the drone ship right there, and the best way to disperse heat energy is with water. If you want to take heat and you want to get rid of that heat, you want to disperse it some way, water is the best way to do it. So they spray the deck of the drone ship down with water, and then when Falcon 9 comes in, you'll see a big white cloud. There it is. It burns off all the water. All the water just turns to steam. And the rocket engine, all that heat from that rocket engine ends up getting dispersed in that steam cloud, and the metal on the drone ship doesn't absorb the heat, so it doesn't melt. I'm looking at these white marks here. That looks like coking. So coking happens, it's just leftover carbon emissions from the engine when they shut it off. When the engine pukes out a little bit of extra propellant every time they shut it down. That's why they purge it out with helium right after, because there's always some residual propellant inside of the engines. That happens with most liquid fuel engines, and even solids too. There's still a little bit of residual. Yeah, Tessa, she's real close. That thing is real close. Could it be salt if they're using seawater? It's possible, Hazarith. Yeah, you could use that salt water for film cooling, and that would explain it. It could be straight up a sodium deposit because they're using salt water on the deck of the drone ship. And I will tell you, the deck of that drone ship is damn rusty. I mean, look at it. It's pretty dang rusty. I mean, that might be the camera. I can't tell. Man, that's cool. Isn't that nuts, dudes? Can you believe that? Can you believe that? But I actually wanted to show you guys something. There's something I haven't really seen before. They showed a shot of Falcon 9 back here. Okay, here it is. Watch Falcon 9. Don't get me wrong. This is a replay. This mission went just fine. It's just something to note. Look at it. See it wobbling back and forth? It's wobbling in the wind. That's probably happened before, but if it has, I haven't noticed it. You see it kind of moving back and forth? It's fine. It clearly wasn't a big deal. And SpaceX is clearly confident that Falcon 9 can perform with that type of wind. But, man, that is weird to see. It's weird to see the thing doing this on the pad. That's like something that you see in KSP, right? It's waving goodbye. Rocket's working. Oh, my gosh. It's got a twang, yeah. I miss the grid fins burning sometimes. It was so metal. Yeah. Look at it. She's rocking back and forth. Dude, that's crazy. That's crazy. Yeah, everything looked real good there. Everything looked perfect. Send it. Wow, that's gnarly. The shuttle wobble is better. I agree. We had some really nice tracks there. This one was just, oh, that's nice. What a great shot. You can see the ice coming off the booster. Really great lighting in here. So the booster is backlit in this shot. The sun's up here because you see the lighter side of the vehicle. So yeah, you're going to have to up the exposure to see this thing. Or no, down the exposure, excuse me. Dude, look at the shockwaves in the exhaust cloud at launch. Let me see. Oh, yeah. I mean, dude, rocket engines are violent. They are very, very violent. Yeah. You could see the crazy pressure shifts that happen inside of the flame trench, because there's so much high pressure gas inside of the flame trench when the thing launches that when it gets out of the flame duct and it gets introduced with the water, yeah, there's little pulse waves that come out. It's really freaking cool, actually. Yeah. I mean, Tessa, these are nicer cameras, that's for sure. Jamie is the one, the videographer at SpaceX. She does a really, really good job. And these cameras were all upgraded pretty recently. Yeah, watch over here. Well, here, let me move my melon out of the way. Watch over here. On the left side of your screen when they show that camera, the flame trench will be pulsating. It's actually really cool. Here, watch. I'm about to get a little... Yeah. Yeah, this next camera shot, look. See that? Isn't that cool? You can actually see the pressure waves from, I don't think it's from the sound, but I could be wrong. It looks like, I mean, they're definitely pressure shifts. Here, let me just go over here. Let's go over here like this. Watch right in here. See? Look at that. And then watch over here. See that flickering? Look at that. Yeah, sound is pressure. I'm not sure what the right words to describe that phenomenon is, guys. I forget what it's called. It's definitely you're picking up the sound waves from the rocket engine. The rocket engine is so loud that it's actually shifting pressure to the point where we can see condensation happening, which is... That's loud. That's really loud. That's really loud. If you can physically see sound deforming, like deforming the atmosphere, like that's really loud. That's really quick. Excuse me, Apollo is stuck on a cliff. Oh, jeez. Okay. I think Jared Isaacman mentioned in an interview that they could feel the rocket swaying in the wind. Yeah, I'd believe it. Hey, Meeps, what's up, dude? Meeps, check this out. You'll probably find this cool. So, guys, don't get me wrong. This doesn't happen all the time. You need the right humidity. You need the right pressure for this to happen. You know, the right atmospheric pressure with the right humid conditions and the right, obviously, temperature would make this happen. But watch. You'll see pulsating happening right here. And what's going on, I'm pretty dang sure, but don't get me wrong, I don't know the right words for this phenomenon. But the rocket engines, look, watch like right up in here. See the pulsating? The sound waves from the rocket engines are hitting that cloud of condensation or that cloud of steam from the overpressure event. And you can actually see, the sound waves visualized from the rocket engine. Right? Watch right here. See it pulsating? You can see it over here too. See how it's like looks like someone's flipping a light on and off? Is that crazy or what? I think that's what's going on there, but I could be wrong. That's the sound. The sound is being visualized. Like you know, you see, hey Whitney, thank you for the raid. Merci beaucoup. Bonjour. You can see the like, you know when they put water on like a bass speaker and it makes all those cool, like you can see the sound visualized? It's kind of like that. Complex fluid dynamic rendering. Whitney, did you watch the launch? Because watch what happens when this cloud of steam gets near the rocket exhaust. It starts pulsating. In the sound waves, you can see them. Good eye, Tessa. Look at that. Look at, you can see the sound waves from the rocket motor propagating in the cloud. Once again, I don't even know if that's the right word for that. I'm sure there's a word for this, but I don't know what it's called. And if you want to see it one more time, you gotta watch it at regular speed. You'll see it a lot easier that way. Yeah, we did. Yeah. Watch this. Look! What the frick? That's strange, man. That's real strange. There was a bird flying away. Yeah, Crispy, that happens sometimes. Burbs get in the way and it becomes chicken dinner, if you catch my drift. But anyway, Whitney, thank you for the raid. I'm glad you guys enjoyed it. I'm glad you guys had fun covering the launch too. For the people that don't know, Space Explorer W, Whitney is kind of my French counterpart for this stuff. If you need a French-speaking stream for launch coverage, she's the one for that. Retropropulsive supersonic. Whoa. As do frogs. Yep. Rocket kill. Road kill. Yeah. I mean, dude, no problem, Whitney. Of course. You do a good job. I tune in when I can, which is not very often because I'm busy streaming. First world streamer problems, I guess. Last. Chief, what's your last? Your last is your last, okay? They look like they're bouncing off the ground. That's probably what's going on too, yeah. They're reverberating out and it does bounce off the ground. That's part of the reason why, guys, that's part of the reason why they spray the pad with water. That's what that big steam cloud coming out of the rocket at, like, if you notice, that they'll turn on basically the waterworks here. That's the reason, Chief. It's the sound suppressors. That's what this one is for. So there's a sound suppressor and then there's a deluge system on 40. So the sound suppressor is these fountains up here, right? And then there's a twofold deluge mechanism that I'm pretty sure. If it's like Slick 41, it should be similar. They're right below the rocket engines. They spray water in, and then they spray water in at the end of the flame trench too. That's the deluge system. What that does is basically it quenches the flame so it doesn't melt the flame trench. The sound suppressor, though, is to prevent those waves reverberating off the pad and actually damaging the rocket. Believe it or not, rocket engines are so loud and they cause so much vibration that they can break themselves. They can literally shake themselves to pieces from the sound reverberating off of the ground. Yeah. Yeah, Tessa, it's pretty crazy. Here, show that again. I thought that was rolling shutter. Yeah, no. Not in this case. I don't know. Too many people telling me to see your last. There's too many of you in here. I can't keep up. Type it out again, fellas, for everybody. If I didn't get your last, type it out again. I don't want to scroll through and look. There's too many. There's too many people. Décollage. Oui. You're supersonic. Thank you. You too are super. We are all supersonic on this day. I had a screening interview as a service tech at the Intel chip foundry here in ABQ. Yo, all right. She's basically French EJ. That's how I described her to people when I first found her. French EJ? That's fine. Yeah. Oui, oui. Chat has reached max Q. Chat can no longer scroll back. Yep. Nah, I'm hypersonic. I'm orbital velocity, bruh. Bruh. Look at that, man. So this is the replay from the Starlink mission. Everything went okay. It's textbook. I mean, it was so textbook, guys. Here, I'll get to the landing. I'll show the landing again. This thing landed dead center on the drone ship, maybe with like a 3 to 4 inch deviation. So what's 3 to 4 inches? About 100 mil. Yeah, 100 millimeter deviation, like maybe this much. It's not a lot. It's pretty crazy how dead on it actually ended up. Oh, we super green? See, last two. Literally just said stop doing that. What's your last W? You need to ask SpaceX to put a chicken or a turkey in the flame trench. It's too much, man. There would be no turkey left. And it would be wet. But also, I mean, we should, but you do. I mean, believe it or not, if you put a rotisserie chicken in the flame trench, that's technically Per engineering, that's foreign object debris. So that decreases odds of mission success, even by a little bit, and you don't take chances with this. What happened with 6 tons per second? 6 tons per second. 6 tons per second per second per second. Xeon with 6 subs. Thank you very much. Banana time. What is that? Oh, nice shot. Great, great picture. 6 tons per second. 6 subs per second. Yep. AJ260-2. It's a good motor. Pretty good. Look at, watch. We should be able to see the. Look. Yeah, see it right there, just below the left grid fin. There's the drone ship. Man, you got really clear skies out there in the Atlantic today. Look at that. It's right there. All right. Can you eat 6 subs per second? No. No caps. Yeah, T-Man. No caps. Very calm waters out there today. Very calm waters. Very nice. Look at this. Look at. Oh! Dude, it doesn't get more accurate than that. It's pretty dang close. Like I said, maybe this far off. Now, I want to remind everybody, Falcon 9 is 3.7 meters in diameter. 3.7 meter this way, and about, 50 meters that way? So, if you don't understand what meters means, it's like 18 feet wide and 150 feet tall. That's a 15-story building coming back and landing with the precision of about this, with a deviation maybe 4 or 5 inches, which is okay. Yeah, you know what, SpaceX? I made my bed today. Boom. You might be able to land skyscrapers from space, but I made my bed and I did the dishes. So there. 3.7 is 12 feet. Oh, thank you very much. I always forget that one. Floating, there's weird bits of information about the rocket that I always forget. But I didn't make your bed today. Meeps. You got to keep up appearances, man. You've been to space. You got to keep up appearances. What the heck's the matter with you? What are you doing? You want a fresh one? By the way, about the wiggle. I don't know that much about rockets, but I do know that steel or concrete structures have a certain amount of oscillation, and they wanted to be built that way since too rigid of a structure means a bad outcome. Yeah. I mean, hooded, like I said, it is well within the tolerances for Falcon 9. It's clearly okay. It's just a little bit windy. What Hooded is talking about, guys, in case you haven't seen it. I live alone. Nobody has to know. I just did out myself here, though. I mean, that's your problem, man, not mine. You could have just said, yeah, make my bed, but I suppose honesty is the best policy. I actually did make my bed today. No, you're not seeing a picture of it. Show us the bed. No. I'm not showing you where I sleep. That's weird. That is very strange. Some streamers might be okay with that. Not your boy. Anyway, look at the rocket. Watch. See? Look. Big, long dong-shaped thing. Look. See? Look. It's wiggling. See it? See it moving back and forth? See? It's the internet. You guys must love this. See it? See it moving back and forth in the wind? I mean, and Hooded, don't get me wrong. The exact same thing that you're describing with dynamic loads on dynamic wind shear loads on buildings. It's the same thing happening with that. It's supposed to. They probably figured that it's supposed to do stuff like that just a little bit, but it's still cool to see. Speaking of my boat. Oh, nice. Hey, Gil, 27-month resub. Hey, what's going on? Oh, we just watched Falcon 9 do its thing, and it was amazing. So I want to be very clear again, fellas. That booster flew 20 days ago. 20. It not only did it fly 20 days ago, but it flew 20 days ago with people on board. It delivered the AX-1 mission, which is all right. What, did you hack my browser data or something? No. 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 PHP, do the grid fins do the steering on the way back down? Yes, yes, absolutely. So there's a combination of things going on here, okay? So you have your supersonic retropropulsion, right? Here. Let's just watch the horizon of Earth here. Okay, so this is right after stage separation. The fairing just popped. Watch the left camera and watch Earth's horizon. Ready? Right now, the booster, when it separated, was facing, you know, east, right? But as the booster moves around the Earth, right, you know, you go further and further around the Earth, by the time it comes back into land, if it stays in this direction, the engines will be facing towards the atmosphere. If you look, right, keep going, the booster's basically perpendicular to the ground right now. The booster's like this, ground is like that. Okay, and then you should see the horizon. See, there's the horizon, and the grid fins aren't doing anything right now, Di. They're not doing nothing. The only thing that's keeping this booster kind of on its trajectory is the nitrogen thrusters. You'll see them just pss, 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 here in a second. Is that fish Jenga? No, he said it again. So see the nitrogen thrusters? That's just compressed air. It's very similar to the gas that you use to like clean a keyboard, only it's nitrogen. That gas is CO2 that you're using for like keyboard cleaning. Now, after the entry burn here, supersonic retropropulsion. See, did you see the grid fins? Take a look again. That's when the grid fins kind of turn on. Ready? Watch them. Zzz! See them? All Block 5 boosters, Bill. They standardized it. Now, after the entry burn, so we're still Falcon 9 right now, 52 kilometers up. That's 50,000 meters. That's a long way. We're still about we're about 150, 180,000 feet up. Flight level 1800 here. I mean, she's coming in hot. Look at that descent rate for the pilots. That thing, pilots understand descent rate. Yeah, that's pretty quick. That's like 1 kilometer every couple of seconds, which is, so that's 1,000 meters. That's 3,300 feet. 3,300 feet per second descent rate. Yeah. Okay. It's coming in a little quick. Now, look. See the grid fins working here? After the entry burn, that's when the grid fins really do their thing. We should be able to see the drone ship down here somewhere. See? As you get down closer and closer to the atmosphere, pressure starts increasing again. You see how you're seeing a really big color gradient right here? Okay? There's a big color gradient here. The sky starts to get blue again. Well, what that is that's the gases. The light's starting to reflect off the gases. That's why that's part of the reason. I'm pretty sure that's the blue sky thing that, you know, like, you can see there's the blue sky, there's the darkness beyond it, right? And then there's the clouds and stuff. Right around here, you could see that because it's on a gradient, that means your atmospheric pressure is going up the closer you get to the surface, obviously, right? Like, we can breathe down here. You can't breathe where that Falcon 9 is right now. It's 30 kilometers up. That's, for everybody else that doesn't use kilometers, so 30 times 1.6, or no, divided by 1.6. No. It's about 19 miles up. That's a long way. You can't breathe up there. No way. You can't even breathe up here. So now, why do I use breathing as a metric? Because, well, planes fly better down here than well, not necessarily. Planes are more maneuverable down here than they are up there because there's more air that the wings can move out of the way, but you can't go as fast, which is why airliners fly up there. But even then, guys, this is way above airliners here. That number needs to be, let's see, about 10. When this number reads like 10 to 15, that's where airliners operate. We're still double the height almost. More than double the height of where like a 747 would be, which is crazy. This thing goes way up in the air. Right? So even then, like I said, I'm using breathing as kind of an example. Up here, you wouldn't breathe. You'd suffocate very fast. Yeah, there's very low pressure up here. So pressure is needed because if there's no air pressure, the grid fins don't do anything. You'll really see where they come into their own. They come into their own, believe it or not. I know this is going to sound crazy. They really start steering around a lot right when it gets to the altitude that most airliners fly at, because that's when the pressure is good enough for an air control surface to work. That's why jets fly up there, and that's part of the reason why they can't fly any higher. Wings don't work when you get high enough up there. They don't work very well unless you have space shuttle wings. Those are the only wings that work really well up there, and U-2, I guess, but. So right there, where the first stage is, right here, is right around where the airliners operate. That, they cut the camera, but you'll see it. Shut up, goalie. So is this corridor clear from flights too? Oh yeah, absolutely. There's a NOTAM. Now, so this is why I kind of scrolled back, because I saw your question going off the screen. You could start to see the grid fins work here. Got stuff stuck in the optical lens on the thing. Give me 1 second. There's dust in the lens on my mouse, so the mouse is not mousing very well right now. There we go. Cool. So you can start to see the air working. Not the air working. You start to see the Falcon 9 get back right down into the atmosphere. So we're 6 kilometers up. 6 kilometers is 6,000 meters, so we're, I don't know, between like at 18,000 feet right here. So we're back in VFR for the pilots, if that, yeah. See what I did there? Yeah, okay. Cool. Not a very funny joke. So this is where you start to see the Griffins really do their work. And the phenomenon that you're seeing right here, and keep in mind, this doesn't happen every time. This is very dependent on temperature, pressure. Temperature can influence pressure. This depends on humidity. But you see condensation around the grid fins. What you're seeing here is drag visualized. The grid fins are, because drag is a byproduct of lift, because you get differential pressure. You have low pressure and high pressure. Basically, the area behind this grid fin is really low pressure. So the air that gets compressed inside of the grid fin, inside of these little cavities right here, immediately depresses when it comes out the other side. So you get some really, really nice flow phenomenon here. See it going on right there? The air is condensing after the grid fin because it's going from super high pressure to super low pressure. It's a Venturi effect almost. Same thing that like a carburetor does. But it was only for a second. It must have hit a patch of humidity or something right there, because it's not really happening much on the other grid fin. But then again, we can't really see it because the sky is in the way. See? Is that nuts? Another interesting thing to note is that you see a little bit of condensation on the outside of the grid fin. That's the air, the laminar flow that's coming up the side of the booster, because the air is flowing all around the booster. Some of that is getting compressed up against the grid fin mount. And then it gets compressed and pushed out of the way and then depressurizes immediately because it's compressing up against this, because the booster's flying backwards. See a lot of depressurization right there, a lot of low pressure. That's really freaking cool. That's one of my favorite parts. Look at that. And then as the booster slows down, right, this phenomenon goes away because you need to accelerate the air through the grid fin to get it to depressurize. And now, see the grid fins wobbling around? Now they're really doing work. Down here, 4 kilometers up, so that's about 10, it's like 12 to 15,000 feet. This is where the air pressure starts exponentially getting bigger until you get down to the surface where it's 1 bar or about 14 psi. Now these grid fins are really, really working. You can tell because they're oscillating like crazy. That's the grid fins doing this because they're trying to move so much freaking air. So do they have NOTAMs and TFR for the landing zone? Every flight, goalie. The smoke that you're seeing down here is them flowing the propellants into the engine. It's the vents on the Merlin 1D that they're about to restart here for the landing burn. That's why that's gaseous oxygen coming out of the engine. There you go. You have an engine ignition. And we know it's a good engine ignition because honestly, you're seeing a lot of unburnt carbon coming up the stack. See all this kind of like dark gray cloud right there after the flame? Merlin 1Ds run very fuel rich for temperature, well, for power purposes and temperature purposes. And a lot of unburnt soot is coming out of the gas generator and out of the motor. So you know that engine's on because you see flames and then you see the dark clouds right after it. Now this thing is really, really working. She's really working. You can see the vibrations from that engine is shaking the whole thing. Also, the crazy deceleration coupled with the vibrations is causing it to really freak out. The grid fins are going to steer, but the grid fins are only so good. They're only good to a certain speed. Think about it like this. The grid fins are only good for a certain speed for the same exact reason why a plane needs a runway to take off. Because at certain speeds, the grid fins don't do anything. They just cause drag, and they don't move the air in the direction that you want. So once this thing really gets below, well, about takeoff speed, or like V1 for an airplane, for like a 737 or something, you'll see them just, they'll lock into position. Watch. They're going to be steering until Falcon 9 figures out that it's over the drone ship. And Falcon 9 knows when it's over the drone ship because it has a downward-facing radar, kind of like a fighter bomber. There are certain versions of like fighter planes that have a downward-facing radar that's designed to find like bombing targets or whatever, right? Falcon 9 has something derived from that, and that radar is looking for the drone ship and it's locking into it. And once it figures out from that radar lock that it's over this thing, the grid fins will lock into position and then the landing legs will deploy. It happens very, very quickly. So see, they're still turning. They're still turning. Now it knows it's over the drone ship. The grid fins, they lock into position and they stop moving because there's no need for them to move anymore. You're going so slow that they're not moving enough air to be able to be used as a control surface. This portion right here is entirely reliant on the attitude control thrusters up at the top to keep the booster kind of straight up, but more the gimbal on the E1 engine on Falcon 9. So that's the center engine. Falcon 9 has 8 engines around the outside, and then it has the E1 engine in the center, and then there's 2, 3, 4, 5, 6, 7, 8, 9. Now that the grid fins have locked, you're all on gimbal. There's all gimbal here. The gimbal has to perform a balancing act here. Most rockets have a very, very high point of instability right after liftoff, because you're relying. The aerodynamics haven't really. You haven't used rockets when they go fast enough. They use the aerodynamics for stabilization, like an airplane. That's why an airplane has the rudder and the elevators in the back. So, in this like kind of point here for a second, you're relying basically off the thrust from the rocket engine to steer and also land. You'll see the gimbal kind of move around a little bit after the grid fins lock, and you can tell it's moving around because the rocket will kind of move left and right. But it couples that with the attitude control thrusters because the grid fins aren't doing anything anymore. Because you're going too slow for them to do anything. And this thing is entirely reliant on gimbal right now. Watch. You see the whole booster kind of drift to the left to get that bullseye. See that? And then it corrects a little bit, brings it back to the right just for a second, and then it shuts off. There it goes back to the right, and plop. I forget what that point of instability during launch is called. I don't remember what it's called, but there's a point for like the first 5 seconds of a liftoff, and in Falcon 9's case, landing, because reuse, boom, where you're very unstable. It's like balancing a broomstick on your finger. You missed another one? Yep. Yeah, exactly, Blue. You got it, buddy. This part is that's a very dangerous part. In fact, this is the part that, when SpaceX, I've noticed I mean, because I've been watching these things land. I've been watching these things land since 2015. I watched the first Falcon 9 land. I watched the Orbcomm 2 mission. I was there December 22nd, 2015. Or 21st. It was kind of 21st into 22nd because it was at night. But these... SpaceX always was able to get the rocket back to the launch site. It's that balancing act for that, like, 5 seconds that they couldn't get right. That's what all the rockets that didn't really land correctly had problems right there. You know, either running out of fuel or overcorrecting with the gimbal and flipping the thing over, which is a guidance problem. They probably had to tweak the PIDs in the guidance system. If you know PIDs, you know. Basically mess with the autopilot to make sure it doesn't overcompensate. That's the plain English way of saying that. Isn't that point just the center of gravity? What do you mean? Yeah, making a rocket hover is very difficult to do. Yeah. That was fun, Tessa. It's kind of sucked for Astra that day, but that was fun. Sticky throttle, ran out of O2. Yep. I mean, because how I like to describe rocket motors to people, like, you don't flip it on and you flip it off. It's not like a car engine. Rocket motors are more like fire hoses. Like, think about it like that. If you visualize like a water heater with a fire hose shooting out the bottom, you know, you don't just clink and the fire hose shuts off. There's always some residual in there. So getting one to throttle, like throttling a fire hose, right? Getting one to throttle and getting one to steer in the right direction is very difficult. You picture firefighters in your mind, right? There's usually like 3 or 4 of them holding that damn hose to get it to point in the right direction. For the exact same reason, because a lot of mass is being shot out of the bottom of this thing very quickly. But this is very unstable right here. It's crazy to me that they freaking got this down pat. It landed right in the bullseye. Yeah. All right. We'll watch the failure video. I don't want the failure video up for very long because it'll picture on the thumbnail, and I don't want to clickbait people. So I'm gonna switch the title over to Space News. All right, so anyway, the Starlink 43 mission went just fine. Everything was A-okay. It was a great mission. 1062, the first stage, did land. We're waiting payload confirmation of deploy here for the Starlink satellites, but yeah. I haven't read the Astra report yet, guys. I didn't really have a chance to. Oof. Yeah, see? It's always these very unstable points where the rocket, yeah, doesn't really. Oops. Yeah, that one, the engine sensor, boom. That was the flight termination system that did that. It realized the rocket was upside down and said, nope. Nope. Yep. See? See, look. The grid fins aren't doing anything right now because they really can't. And you're relying on engine gimbal, and yep, that one didn't really... Yeah, that one didn't work. That didn't end well. There goes the COPV. Skeer! Yep, see, there you go. There's an overcorrection. See the nitrogen thrusters trying to do their thing? They're trying as hard as they can. It's like, no, I got it. Don't got it. You klutz. Hope it wasn't a deposit bottle. Skeer! You know how I always tell you guys about the helium tanks that purge out the motors and stuff? Well, there they are. Turns out that there's still helium in there because they were, if the rocket had landed correctly, they would have shot inert gas into the engines to clean them. But, yeah, that didn't happen here. There's one. And there's one spinning around on the deck right there. That's good. Yep. We watched that launch live in 2016. I remember that. That was good. That was a fun time. Yep. Yeah, that's why they made the Octo Grabber. SpaceX literally has an autonomous rocket that's sitting behind the it's behind one of the deflectors on the drone ship, and the deflector opens up. Now, this is before they had it, obviously. This part is like a little garage door. It opens up, and this tracked vehicle comes out, and it grabs Falcon 9, so it doesn't do that. Yeah, that's, yep, that's, a Falcon Heavy fell off the drone ship doing that. Falcon Heavy core. And there, didn't get your mixture right. Boom! I can already tell you, I can tell you just by this camera what they ran out of. Chat, you tell me. There's 2 commodities that are being fed into that rocket engine right now. Liquid oxygen and rocket propellant 1. You tell me which one they ran out of. They ran out of LOX. You know how you could, you're right. You know how they could tell? You see the big cloud of carbon that gets shot out right there? That right there, that dark cloud is fuel rich, which means you ran out of oxidizer. And once you run out of oxidizer, it goes very fuel rich like that. You've made a nice blowtorch. Rocket engines that, when they don't get to the pressure that they need to fill up the combustion chamber with explosion, they turn into really, really nice flamethrowers. Spaceballs the flamethrower! The kids loved this one. The legs are on fire because, yeah, they got doused in basically charcoal. Yeah. And then the fire from the tank exploding. Yeah. Oh boy. That's the one I watched. I was there, man. Yeah, see, that was the first drone ship landing. Look at how far that is off kilter right there. You ain't centered on the ship right there. And if you think about it, anybody that knows anything about, like how ships work in the ocean and stuff, well, you have about 40 tons of mass that's not on your keel right here. Starboard side. And if the ship is rocking back and forth, and every time it rocks, that thing goes further and further to starboard, you get a compounding loss over time. Like, every time it slides a little bit further, as you get closer and closer to the edge, you get further off the center line of the drone ship, and the drone ship lifts further to the right, further to the starboard. Yeah, that's not good. Yeah, that's how the boosters fall off. It has happened, but yeah. The platform seems to be built really good. Pierre, it's a barge. Yeah, it's a big, heavy moving barge. And so what SpaceX did is they lifted oil rig thrusters. They're called azimuth thrusters. They literally went and bought surplus azimuth thrusters from an oil company, and they took the guidance system from an oil rig to keep a floating oil rig centered over a well, using like GPS, and they just lifted it and put the oil rig thrusters and the oil rig guidance system on the barge. That's it. That's all it did. Is that nuts? What's the size of the barge? It's like... it's almost the size of a football field. Almost. I'm going to say probably a hockey rink. Like a NHL hockey rink. It's pretty damn big. Yeah. Yeah, a hockey rink is fine. It's somewhere between an American football field or European rest of the world football soccer pitch. It's between that and a hockey rink. About halfway. It's pretty freaking big, dude. The bees just made it. Thank you. SpaceX have had over 10 missions this year. Yep. 300 feet long, 100 feet wide. So 100 meters by 33 meters. It's pretty big. Yeah, that's not a football field, but it's almost a football field. It's pretty... actually... no, it's about a football field. Yeah, closer to a football field than a hockey rink. You could fit a hockey rink on it.
Discovery, go and throttle up.
Blood fam? 34-month resub. Yeah, they're pretty, that is a football field. Both football fields, American and rest of the world. They're pretty much the same size. Jeez. Yeah, that thing is, yeah, it is. Frick. It's pretty big. And the rocket's landing takes up almost all of the space. Like I said, Falcon 9 is about as tall as a 15-story building. It is not small. I've stood next to one. It's not small. Very, 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 very large. Very large. Very large. Anyway, yeah, guys, I hope you guys enjoyed that. You want to jump into some space news? Camera takes 10 tons off or something. That's what she said. Are you proposing they put goalposts on the barge? I mean, they got a bullseye. What more do you need? I mean, they got a bullseye. Actually, you know what, Gigi? You know what would be cool if they painted the lines on the drone ship for a soccer field, right? Or a football field. You know, like you mark the 50-yard line, 40-yard line, 30, 20, 10, and the touch and the end zones. That would be actually a really good way to convey the scale. That'd be a really good way to show how big that thing is, because everybody understands how big a soccer field is. Everybody understands how big a football field is, an American football field. That'd actually be, it's not a bad idea, dude. Put a dartboard on it. A football pitch would be best. It's got the center circle. Yeah, we got the 50-yard line and the hash marks. It'll work. It'll work just fine. Put some uprights at each end. No. Here's the 5-head move. Make the antennas on the drone ship look like the football uprights, because the ends of the drone ship already look like soccer goals. They look like them already. Elon's face. Can you imagine if he's making a ha face? That'd be awesome. Oh dear, that would be pretty funny, actually. Oh my goodness. The memester. What about a hockey rink, bud? Oh, you could fit a nice hockey rink and a nice stadium on there, bud. It'd be really nice. Do you see that? Another Starship delay? Oh, is that what we want to talk about? Okay. Who cares that the regulatory stuff is predictably delayed? Any hopes of a flight in the near future have already been crushed because of the Booster 7 downcomer. That's from Scott. Yeah. I mean, Supercraft, I'll be honest with you, that's not something I didn't know. Like, it's not something we didn't know. Heck, even when they, at the turn of the year, right? At the start of the year, I said, like, you know, even if the FAA had been done by 2021, I don't think that SpaceX would have been ready. So, like, and this is what I mean. I think that what's going on with SpaceX and the FAA is a compounding issue. So, SpaceX basically said, we want to see an orbital launch by December of 2021, right? And the FAA said, okay, you know, we'll get the PEA done by October, or by December of 2021, right? We'll get it done by December 2021. And then, you know, December 2021 comes around, and the FAA said, nah, it's going to be February. It's going to be February. So SpaceX probably said, well, okay, if it's February, we can introduce a bunch of upgrades. No problem. Then February comes around, and the FAA says, I mean, are we good now? And SpaceX says, no, we're not ready. And the FAA says, okay, we'll delay it to March, no problem. And then SpaceX maybe was ready with Booster 4 and Booster 20 in March. And then March comes around, and the FAA says, no, we need till April. And SpaceX said, fine, okay, you know, that's all right, I get it. And then they choose to upgrade something else. I think it's compounding. I really honestly think that's what's going on. I don't think that there's any nefarious purpose here, but I mean, even if there was, I wouldn't be able to prove it. I wouldn't be able to prove it anyway, so... You know, we wouldn't know. There's no way to prove it, you know? But, I don't know. Maybe that's just me. You think the FAA and SpaceX are in a sort of James Webb moment? No, not really, Tessa. I'm good, Hokey. Hey, X, what's going on? You ready for spa tonight? Your boy got a job offer to do science stuff for the Navy. Whoa. Whoa, look at you. That's pretty cool. Bezos is paying off the FAA to keep delaying it. Yeah, Dragon, like, look, when it comes to the PEA and SpaceX, like with the FAA and everything that's going on, I hear people float all kinds of crazy stuff, like, oh, you know, the president doesn't want SpaceX to succeed, or they hate Elon, or they're purposely making SpaceX drag their feet so they can be competitive with NASA, blah, 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 you know, oh, it's a politician's fault, it's this person's fault. First of all, you know how I feel about blaming people? You know, people that can't solve problems blame people. Yeah, straight up, first and foremost. If you can't solve the problem, you're just going to blame somebody because you're not smart enough to figure out the problem. Second of all, and people might not like that I said that, but it's true. You can say whatever you want. Take ownership of the problem and fix it. Well, but, you know, see, here's the other thing. We can't fix that problem. So I don't know why you're letting people letting it occupy their headspace. But anyway, the second part of that is, even if that was true, we could never prove it. How could you prove that they're dragging their feet on purpose, even if that's what's going on? There would have to be some cataclysmic leak or something crazy to happen to kind of expose this. I'm not saying that it is true. I'm not saying that it isn't true. What I'm saying is that I don't know. There's no way to prove it. Heck, my theory, which is, you know, about it compounding off back and forth off of each other, is probably what's going on, but I still can't prove that. So, I don't know. I don't know what to tell you. It's George Washington's fault. Way to go, genius. Yeah, right? I was joking, by the way. Nah, I know, man. I know. I always feel the need to bring this up because I don't, like, you know, you can sit here, you can blame this person, you blame this person, you blame this person, or you can fix it. You know, like, and once again, I think at the end of the day, everybody just wants to see Starship fly, and I think at the end of the day, everybody wants to see SLS fly, and I think we're jonesing for a Starship launch. We haven't had one in like a year, you know. I think that's everybody wants to see this thing fly, man, or explode or whatever, you know. Fanboy's gonna fanboy, yeah. I don't know, man. Yeah, it is what it is. Like, once again, these are problems that we can't solve. And even if you know, you can have theories on it, and you can't prove them, though. Even if it was true. Now, I don't know. Like here, one more thing. A little bit of additional thing on the PEA and whatnot. Something that I have to be careful of, okay? You got to be careful of this. Is not to let your feelings screw with your judgment. Now, I don't know if this necessarily applies to anything else. I don't really care. I'm talking about in the application of spaceflight here, right? So, what's the context to that statement? The context is that we want to see Starship friggin' fly, man. We want to see Starship fly. Right? And it's no secret that, you know, SpaceX is causing ripples, right, in the pond. Absolutely. They're upsetting the market on purpose. Like, that's the whole stated goal, right? And, you know, that's no secret, but my feelings are saying, like, yeah, they're screwing Elon on purpose. They're screwing him on purpose. But, you know, that's just an emotional response to me wanting to see Starship fly. And you know how well having your emotions and feelings denote your actions works. That doesn't work very well when you're trying to critically think. And with spaceflight, you have to. Like, I'm not saying you shouldn't let, like, empathy guide you or something. That's probably a good thing. But in this particular case, you can't let that cloud your judgment with spaceflight because someone's going to get hurt if you do. You know, STS-51L, Challenger is a very good example of this. They wanted to see it launch because, well, when are we going to launch? Sometime in January, like in June? We got to launch it now. We got to launch it today because I want to see it launch because it'd be good for blah, 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 blah. And then it launched and then it failed. You can't screw around with this stuff. Don't screw around with this. And how bad would it be if, like, a test starship was coming into land and it landed and it missed and it hit, like, an endangered species or something? And it wiped out an endangered species. Does SpaceX really want something like that? Do you want to give the SpaceX haters more flack? No, absolutely not. You know, there's already a lot of people that are, you know, like astronomers don't like Starlink, for instance, and now you're going to piss off the environmentalists, and that always ends really well when that happens, right? Like, I think that it's probably better that this, you know, like, even though my heart's telling me, like, frick 'em, launch the thing. You know, why is this taking so long? You got to think about this. You got to be clear about this. This is only a couple of months delay, 6 months, maybe even a year. If it's a year, so be it. That's fine. It would suck, but if it's a year, it is what it is. That year, for that year, right? We're going to be sitting here doing nothing, but that means the next 20 years are going to be Starship launches all the time. Got to be patient. Can't let your emotions guide you in this particular case. With spaceflight, people can get killed if you do. Like, don't screw around. Heck, a lot of people don't know that during STS-1, ground service crew died. A pad closeout team member died because he inhaled hydrazine from the space shuttle. Yeah, hydrogen gas, I think it was. Yeah, like a couple of days before STS-1 launched, yeah, somebody died on the pad. Yeah, see, you gotta be careful. Just hit the space bar. Yep. You can go look it up. I forget what it was, if it was hydrogen or hydrazine. I'm blanking on it, but yeah. Just chill. You know, I'm jonesing for that Starship launch as much as anybody else is. Trust me on that one. Like, this thing, freaking launch it, man. Come on. But anyway, yeah, I think that's covered. I think I covered that pretty sufficiently. What else do we have? I'm trying to look through, where else this is. Alright, so let me compile the rest of the space news here, fellas, and then we'll go. I'm trying to look to see what else we have here. It was pure nitrogen. There you go. Yeah, nitrogen can kill you. The thing that you're breathing right now. Too much of it can kill you. Too much of anything can kill you. You know what I mean? Yeah, Bill, I think that's right. Yep. No, Mac, no new article necessarily. Just kind of talking about the PEA. The programmatic assessment got delayed again another month. So, yeah, I know we're all jonesing for a Starship flight, but yeah, gotta have to wait it out. Let's see. Never have to, yeah, right? Look at this. The Endangered Species Act was completed, so we're at 3 out of 5. All right. If you guys want to look, this is the permitting website for it. Let's take a look. Okay, they're finishing the overall environmental assessment. Endangered Species Act, that's complete. Good, good. That was That's already done. Endangered Species Act consultation. Overall project timetable. That's completed. We're waiting for Section 106 review. Action. Section 106 review. Responsible agency. Department of Transportation. Bureau, Federal Aviation Administration. In progress. Ever looked at the SDS for monohydrogen dioxide? You didn't say that right, Druid. I know what that means. Drinking some right now. Today the FAA is more good news than bad news because people still complain. Yeah, Thomas, that's what I mean. They're not thinking about it clearly. They're just, my team, no. Their team bad, our team good. You know, Team SpaceX, screw everybody else. Yeah. Okay. I mean, like I said, I'm really happy that the people that are complaining about it aren't the people in charge of the FAA nor SpaceX. You don't see anybody from any one of those entities on either side complaining about anything at all. You ever see Elon throw the FAA under the bus? Never. Never will. Because those are the people making the decisions. It's fine. What happens when an endangered species is consuming an endangered plant? Usually there's a symbiotic relationship there. If the endangered species is consuming an endangered plant, then usually that plant finds a way to grow more because you're taking matter and putting it somewhere else. However, Gigi, there is, in environmental conservation, there's such thing as an invasive species, where a species gets introduced into an ecosystem where it's at the top of the food chain and it screws up the entire ecosystem. Oh, that happens all the time. An invasive species is happening in Texas right now. Wild hogs. Yeah, in the southern part of the U.S. Wild hogs. The government will pay you to go hunt hogs because there's overpopulation, and they're literally killing off everything else because they're wild hogs. Didn't he complain that the FAA is too slow to administer daily launches? Yeah, he did that a long time ago, Sebi. I guess that's right. Yeah, he has before, but has he done it lately? And honestly, if he does, that's not a good look for SpaceX. All that's going to do is make more people not like you. And once again, I'm not really sure Elon gives a frick, but who knows? Wild hogs are a serious thing. Alucard, the U.S. government will pay you to go and hunt hogs because of overpopulation. Oh, yeah. How much of the endangered species become endangered because humans? A lot, Kane. Buffalo. Panda bears, elephants. Tigers. Take your pick. Elephants, very much because humans, because of their tusks, the ivory tusks. It's a very sought-after commodity. A lot of things are made out of that. Rhinos, cheetahs. Yeah, oh yeah, like I said, humans fought to be at the top of the food chain, but, you know, we've killed off a lot of other apex predators to get here. You know what I mean? You don't add 7 billion people to this planet and hope that the climate is going to change the same, or remain the same, right? Change the same. Sorry. Yep. Not enough sleep. It's nice to call people's moms hogs. Wow. Yeah, I'm sure, Tomas. Yeah. Oh, yeah. Are humans an invasive species? This conversation's getting a little deep, Kane, don't you think? Shouldn't we go back to space news? Yeah, interesting, Sebi. I think the FAA doing due diligence is legal protection for Starship. Legal action is likely to do terminal damage to a commercially operating Starship. Bingo, Bond. That's what I'm trying to tell people. Dude, you know what? I hate that it's taking a long time. I hate it. But you gotta think about it for a second. If the FAA crosses all their T's and dots all their I's, and, you know, a Starship has a problem, and that problem was accounted for in the environmental assessment, like one crashing or something, or Super Heavy missing the tower or whatever, that's already taken into account. It's minimal impact on the environment. Nobody can complain. No one's going to file a class action suit for environmental damage for SpaceX. And even if they try, nope, covered in the PEA, on record, notarized, boom, nope, sorry, nothing. It's legal protection for SpaceX. It's smart. And I know, like, it's going against every fiber of my being saying, like, all right, fine, for it to take more time, like, that's okay. But that's the right move. I think you're absolutely right. Anyway, let's, I'm going to look around and see what else we got here. Now, we do have the updated Starship footage today. We could go see what's going on while we're there, and then we could go check out some other things. Let's see what we got for the Starship video. Let's take a look. So this footage is coming from Boca Chica Gal and our buddies over at NASA Spaceflight. Take a look here. Pretty much, Maker. That's right. That's why there was, you know, I've said this wrong in the past, but that's why there was such a big fiasco over the 737, because they waived some things with the 737 MAX, and then it killed people. See what I'm talking about? We do not want that happening with Starship. You do not want the Starship going, like, having some kind of crazy design flaw in it that could screw something up, screw the environment up, hurt people. We don't want that. That's a bad idea. Yeah, exactly, Creeper. You got to be careful. Look, I know it's bureaucratic nonsense and it's annoying and it takes time. But if they nail it and they get it right, this is what I've been saying for months. If the FAA nails it, they get it right, it'll protect SpaceX legally within the confines of the law, because Uncle Sam said it was fine. You know, that's good. What I've been saying is that, you know, if they do their homework and all that goes through and everything's good, then we're good. We can launch Starships willy-nilly. I mean, they're still limited to a certain amount of launches in Boca Chica here, but, you know, the Cape Pad will be operating sooner rather than later. And then you might see Starships going off all the time. You know, we'll keep an eye out here if we start seeing them scaling Starship parts, like building a lot of them, like if we see ship 24, 25, 26, 27, 28. You know, we know that booster 8 is getting put together. 7 is junk because the downcomer broke. See if we start seeing booster 9, booster 10. I wouldn't be surprised if Boca Chica, because the manufacturing base is already working here, if they moved some to the Cape. You know, before the Starship factory over there gets figured out. You know, if it takes some time, so be it. That's fine. Be patient, because then we could have a plethora of launches by the end of this year. Jefe, what is a plethora? If you do not in fact know what a plethora means, then why would you say that I have a plethora of piñatas? If they approve it, it doesn't guarantee launch, though, does it? It does alleviate. If they approve, that means SpaceX can file for a launch just like you'd file a flight plan with an airplane, and the TFRs and the NOTAMs and everything, then you're good, right? Now, what's going to really bother me, like, okay, so once again, I just used the 737 MAX as an example. The 737 MAX was cleared by the FAA to fly people around, and then it didn't. It flew into the ground, right? That's not good. I don't like joking about people getting hurt. That's messed up. I understand that. I acknowledge it. Stay with me, okay? We do not want something like that happening with Starship. And this is what I mean when I say, this is what I've been saying for months. If the FAA clears SpaceX, right, and then SpaceX launches something,
Go and throttle up.
and then, you know, after they launch, maybe something goes wrong. Maybe they didn't catch super heavy. It missed the tower and hit the marsh next to the launch pad or something. Or Starship came in and re-entered, and it re-entered over a populated area by accident because some of the debris did something that they weren't sure about, etc., etc. And then the FAA says, no, never mind. Nope, no, we got to pull the PEA. That is the point when I'd say something's up. something's up because if the FAA is learning something new about environmental impact that was so much of a big deal to pull the launch license for Boca Chica, that means they didn't do their homework. That means they sat here and delayed us for 6-7 months, and they delayed us for all that time and they still didn't consider it. That's when I'd start to ask questions. That's when I'd be like, wait, why? What do you mean? You were here for almost a year analyzing this stuff. What do you mean? You're telling me it took you a year to read 18,000 freaking comments from on the board? Like, come on now. That's when I'd be like a little bit concerned, because that reeks of something else going on, just like it did with the 737 MAX. Right? That's when I'd start to ask questions. Right now, take your time. It's fine. Isn't it kind of weird that they are trying to fix Booster 7? I would expect them to move to the next one. Seems faster and the easier thing to do. Phil, what I would most likely do is use Booster 7 as a prototype for your new downcomer to see if it works. Yeah. What is a group of starships called? A herd, gaggle, swarm, fleet. Fleet is the word you're looking for. Fleet, baby. I think Starship isn't made by Boeing. Yeah. Nice, Thomas. Axiom, 12-month resub. The infamous Guapo is a mail plane. It's a mail plane? How can you tell? Little balls. Little balls. Some people hypothesize that the FAA is simply undermanned and overworked. Who knows? Possible. Very possible. Yeah, floating. I would also entertain that as a more feasible thing that's actually going on rather than some crazy conspiracy. Is your USA t-shirt the United Space Administration? No, it's just United States of America. All right, some bureaucrats we can offer some. No, Sebi, don't. We got enough. You could. Hell no. Hey, hell no. You can keep yours. You keep yours, and they can just do bureaucratic things over there. We got enough of that crap. Anyway, let's check out the footage from Boca Chica. This is coming from Mary and Nick down there, and obviously from our buddies over at NASA Space Flight. Let's see what we got. This was the footage from yesterday. That's the Liebherr 11,000 right there. You can tell because of the way it is. Yeah, we're starting to do that. Can I get a link to the VOD YouTube if possible? Exclamation point VODs, I think Jockey is. Or no, Fozilla's got it. Thank you. The way you're presenting the FAA as if it is out to take down SpaceX. Are we all not supposed to be on the same side? Mac, I didn't. You need to go back and listen to what I said again. Yeah, no, I said the exact opposite of that. There's the vacuum RVAC thruster dynamic hydraulic thingamajiggers. No, they're the hydraulics for load testing. After watching the Crew 4 launch, I have a question for you. What would Dragon do if it reached the docking port to the ISS but was off-center so it could be locked into place? Has this ever happened with Dragon? It has a guide, Ice Mage. It has a guide. The IDSS soft capture system is the guide piece. If it's off-center, they have an out here. All right. Hold on. International Docking System Standard. So, Dragon has two types of capture mechanisms. There's the soft capture mechanism, which is this thing up here, and then there's the hard capture mechanism, which is these down here. When Dragon is going to dock to the space station, what's called an attenuator lever will push this little plate forward. This plate can retract and extend. This plate is on springs, okay? It's on springs. They're using spring as a damper to dampen out the differential velocity between the space station and Dragon. Basically, when it comes into dock, it'll absorb the shock. Now, what guides it into place? Well, when the International Docking System Standard soft capture mechanism, the attenuator's open, and the soft capture mechanism goes into this upward position. The IDSS, when it's retracted, looks like that. See that? Okay, that's a passive IDSS. That's actually the IDA. That's what Dragon docks to, believe it or not. That thing is up on the space station right now. I'm trying to find a picture of one that's retracted. There you go. There's a retracted IDSS right there. So see how that inner ring is inside like that? It can move up. These lever arms extend and they decompress a spring, and that spring is used for docking. Now, see the pedals right here? The pedals are what line you up. That's your guide. So Dragon can come in kind of like at least a little bit crooked, right? And when it does, this plate will spring into position, the pedals will guide it into position, and then Dragon will just do this. Does that make sense? And then, when the pedals are in position like this, the attenuator hooks, or the attenuator latches will pull this ring downwards into position, and then 12 hooks on the hard capture mechanism will latch into position. These here are basically like a bike lock. It comes and grabs and pulls the two docking ports together. There's 12 hooks. You also have guide dowels on the IDSS. So when this thing does retract while it's attached to the space station, this pin will align it. It's called a pilot dowel. There's a pilot dowel on the IDSS, or on the IDA. You'll be able to see them right here. See? Right there. And the IDA has a pilot dowel going into Dragon as well. There's one there, and then I think there's only 2 of them. But the pedals are what line you up. And then you retract the attenuator so the soft capture mechanism gets retracted, and then these hooks latch with each other. It's the same hook on either side, believe it or not. This one doesn't have an extendable this one doesn't. That docking port that's on the IDA does not have the attenuator system, so it can't extend the inner ring. This is just designed for receiving, not for docking. It's designed to be docked to, not docked from. Understand? There's a ton of documentation out there on the International Docking System Standard. It is public domain. You can go raid NASA's technical resources and read about how this thing works. That's why I know so much about it. When they undock, is it the reverse process, soft capture and then release? Yep, pretty much. Alleviate, they use the springs to spring Dragon away. Yeah, pretty much. I mean, yeah, that's basically it. They use that and a combination of modulating RCS to basically keep this thing aligned. Okay, maybe I'm misinterpreting things. I apologize. You didn't misinterpret it, Mac. You just heard half of what I said. I can think of when you don't get the whole equation, you're not going to get the equation. You're not going to get the final answer, right? If I told you blank plus 2 equals 4, right? I mean, you can kind of extrapolate some things there, but if it's blank plus blank plus blank plus blank plus 3 equals 5, then you're going to be like, what? Wait a minute. Wait a minute. Anyway, yeah, that's Ice Mage. That's how the IDSS works. There's a soft capture mechanism that guides you in, and that kind of does an initial latch, and then they pull the Dragon in. So Dragon can come in misaligned just a little bit. You're never going to get it perfect. It's never going to be exact, but it's going to be close enough to get it to slot into position. Can the Chinese craft dock to the ISS? Don't know. That's bloody cool. Did the Americans come up with the system? It's a collaboration between all the international partners, Alleviate. Even China uses a derived IDSS because they probably raided NASA's technical archives to make whatever their docking port is called too. It is, believe it or not, it's based off of APAS. It's based off of the androgenous peripheral attachment system that that the shuttle used. That's what the IDSS is based off of. It's a good docking system. Orion's going to use it too, which is good. Okay, Cuban, what do you got here? One thing that keeps eating away at me. SpaceX chooses one launch site instead of also having one at the Cape. Wins a Starlink contract for $900 million, $2.89 billion contract to the moon for NASA. Then Elon buys Twitter for $44 billion, well in court for how he spends Tesla money. The extreme equivalent to my $80 billion bar bill when I have no groceries. I feel like SpaceX has been shortchanged. Rocket Lab got pushed out, Katra. Cuban, I gotta read that again. Hold on. One thing that keeps eating away at me. SpaceX chooses one launch site instead of also having one at the Cape. Okay. Wins the Starlink contract for $900 million. What contract? 900? I think that was the Department of Defense one. And then they have $2.89 billion contract to the moon for NASA. Then Elon buys Twitter for $44 billion while in court for how he spends Tesla money. The extreme equivalent to my $80 bar bill when I have no groceries. I feel like SpaceX has been shortchanged. What do you mean by shortchanged? So, Cornbread, I could start going through this if you want. Type out what you mean by shortchanged, or just listen for a second. So, SpaceX is building a Starship launch pad at the Cape right now. They're working on it right now, and they're building another factory that's bigger than Boca Chica at Kennedy Space Center right now. They're basically Control-C, Control-Ving Boca Chica, but at the Cape. And the pad is at 39A. It's just to the right. If you're looking at the pad from the VAB, it's just to the south of where Falcon 9 launches. Second part, they win the Starlink contract, and then $2.89 billion for the lunar lander. But you got to remember that lunar lander contract stipulated that Elon could provide his own funding for the lander as well, on top of NASA funding. He used that as a way to underbid everybody, and that's why SpaceX got the HLS contract. That, and Congress didn't give NASA enough money to build a lander, which is stupid. But Congress gonna Congress. Then Elon buys Twitter for $44 billion. Okay, so a thing about Elon's Twitter acquisition, and I'm not saying it's a good thing, I'm not saying it's a bad thing. Don't get confused. Don't try to make it about that. Elon financed this. He financed this to the tune of $20 billion, and then for the rest of the deficit, he offered his Tesla shares up as collateral. I think I said that right. Long story short, Elon doesn't have $20 billion of liquidity in the bank. He doesn't have $20 billion or $44 billion lying around. He probably doesn't even have $1 billion. Probably doesn't even have $1 million lying around in his personal bank account. If I had that much money, hell no, I wouldn't do that. I would put it all in cars or in fighter jets like Jared Isaacman does. Or spaceships. Go figure. All of his net worth is what the companies are worth. The companies that he has share in. So Elon didn't just have $44 billion just lying around. He financed this and used his Tesla's shares as collateral for the financing. Basically, he owns Tesla, and those Tesla shares are worth way more than $44 billion. So the bank will give you a loan because the bank knows that he could pay it back by cashing out Tesla shares if he has to. They're most likely going to get their money back, and then some. Does that make sense? And she's drunk. Oh, nice. I think Cuban is saying, why isn't Elon using this money to invest into SpaceX rather than buying Twitter? Dude, I think he is. Like I said, he cashed out a lot of Tesla shares very recently. Before the whole Twitter thing came on. He cashed out a lot of shares, Cuban. And I'm pretty sure he's matching NASA's funding for Starship development. And also, the third one is, dude, he's building 2 Michoud-sized factories. Michoud is the factory that they built in Louisiana to build Saturn V third stages. That factory that's gigantic, that's built Saturn V third stages. It's built all the space shuttle external tanks and all the SLS core and parts up until this point, all the major parts. So he's building 2 of them right now. He's building one of them in Boca Chica that is kind of almost up and running. And then he's building another one in Cape Canaveral right now. Michoud was not cheap. The point is, dude, is... Okay, so there's 2 kind of big things to get from this. Okay? There's 2 kind of big things to get from this. Rocket Guy, you already answered. You already said one. So, one, first and foremost, and this is something, Cuban, that I say all the time. Spaceflight is not as expensive as we think it is. It's really not. 2, Elon is spending billions of dollars on SpaceX. There's billions of dollars of investment in SpaceX. He is by far, like, everybody says, oh, they're going to develop Starship and it's going to cost $2 million a pop. It's going to cost $2 million a flight after you spend $15 billion developing it. So, long story short, he is spending a lot of money with SpaceX. Literally, the only entities that I can think that are spending more money than Elon on spaceflight are Jeff Bezos and NASA. SpaceX's budget is bigger than Roscosmos's budget. It's bigger than the ESA's budget. I'm willing to bet that it probably is. It's probably to the tune of like a couple $2 billion per year. If I had to guess, it's up there, man. It's up there. Definitely up there. R&D is damn expensive, Blood Fam. Bingo. And SpaceX is doing a damn lot of R&D right now. They can literally afford to blow up a prototype. Blow up multiple prototypes and it's not that big of a deal. So they are spending a lot of it. Elon is spending a lot of money, but he's spending what needs to get spent. And that's an important thing to understand. Everybody talks about how if NASA had the Department of Defense's budget, we'd be on the moon, blah, blah, blah. You know what? You know what the reality of that situation is? If NASA's budget was doubled from $26 billion to $52 billion a year, we wouldn't be able to just go back to the moon. That's like we could operate the space shuttle, SLS, the Saturn V, commercial crew, Falcon 9, Falcon Heavy, build multiple pads, have the VAB being used by NASA, build multiple landers and probably even a base module for the moon, and probably also work on Mars transfer vehicles, nuclear propulsion, commercial low Earth orbit destinations, on top of an ISS replacement, Skylab, wet workshops, climate monitoring satellites. We could literally do all of that. We could tick everything that NASA needs off the board and probably have a couple $2 billion left over. Spaceflight is not as expensive as we think it is. The R&D is what's expensive. If NASA's budget was doubled to $50 billion tomorrow, they could literally do everything for a good amount of time. Oh yeah. Everything we want. Space stations, lunar space stations, lunar outposts, Saturn V, a complete end-to-end lunar architecture. NASA could bring back the Saturn V, still operate SLS, and probably bring back the space shuttle if their budget was $50 billion a year. If their budget stayed like that for about 10 years, they could literally bring back all of that. All of it. They could refly the space shuttle, they could keep launching SLS, and they could bring back the Saturn V and the lander and everything with modern and updated parts and probably still have money left over. That's ridiculous, isn't it? Spaceflight isn't as expensive as you think it is. So I know what the question you're getting at is, like, if he's spending $44 billion on Twitter, why is he not spending $44 billion on SpaceX? SpaceX does not need $44 billion of investment. That would be pissing away money. But Cuban, I understand what I think you're saying and what other people are saying when, acquiring Twitter is also pissing away money. But Morgan Stanley doesn't seem to think that it is, so who knows? How much funding does NASA get? $26 billion a year, Alleviate. And, I don't know, about 7 or 8 billion of that goes to human exploration operations. So that's like SLS, commercial crew, lunar landers, maintaining the VAB, the pads, all that other stuff. All the factories, Stennis, Michoud, Marshall. Yeah. And then there's the climate side of the thing. It's like half and half. Half climate science stuff or science mission directorate. So that's like JPL, the rovers, climate monitoring satellites, earth science satellites, planetary science stuff, telescopes, like James Webb, Hubble, That's the science side of things. There's the science side, and then there's the human side, like sending people into space. It's about half and half. And then there's like other things. There's STEM outreach. There's a bunch of other stuff. Flying the shuttle was expensive? Not sure what you mean. It was over $1 billion per launch. Yeah, it's $1 billion a launch, Blood Fam, because it's total cost involved. NASA ropes their development money into their launch contracts, and they have to publicly disclose it because it's NASA. Long story short, if you bought a Cessna 172, right, would the price to fly it be just the price of gas every time you go to fly that thing? Hell no. Even though gas is freaking expensive, and I can't even imagine what avgas is right now. It's probably ridiculous. Right? That's like buying a car and then saying, "Oh, it only costs $20 to drive this thing around because that's all it costs to fill it up with gas." Well, what about the $50,000 that you spent on that car? You know what I'm talking about? NASA has to give you the total cost involved. You know what I mean? And even including all of that, cars are usually sold at a loss. The only way to really make money as an automaker is to make a lot of cars. You usually sell per unit cost at a loss, but if you sell more, then you kind of eventually over time make it back because the price of manufacturing one goes down because you made a lot. I get that, but refurbishment of the shuttle was astronomical. Well, yeah, it was astronomical because it was astronomical because NASA developed the shuttle with the Gemini program's budget, dude. So they never really pushed it. They never really matured that design. That was they designed. Yeah, I mean that's the end of the day. The shuttle needed an Apollo-style budget to get that thing to work correctly, but they never did. NASA was by Congress was told to build them a freaking Ferrari. Oh, here's the price. Here's the Toyota Corolla money. Here's Toyota Corolla money. We need you to build and make us a $350,000 automobile. Here's 20 G's. All right, have fun. The shuttle was the point is what I like to tell people is that the shuttle wasn't even cut down in its prime. The shuttle was sabotaged from the beginning, and it's not intentional sabotage. You don't try to build the most complicated vehicle ever devised by man, let alone a first attempt at a reusable spacecraft for the budget of the Gemini program. I'd like to remind everybody that the shuttle is it has a digital processor on it. Full-fold redundant digital processor, right? Multifunction displays out of the box. It's reusable. It can take 25 tons into space and deliver 8 people up there at maximum, all in one shot. And it has reusable Hydrolox engines, that's crazy in its own regard. And NASA developed it for the budget of the Gemini program, a program that was using converted ICBMs to launch an analog capsule into space. The Gemini capsule didn't have a computer in it, guys. Didn't have a computer. The wiring is about as advanced as a car is nowadays. Not even, because cars have computers in them. The Gemini capsule was analog. The guy writing math, Buzz Aldrin was writing math out in the frickin' capsule to try and figure out how to rendezvous. He's frickin' doing the math out on a frickin' piece of paper to get rendezvous figured out. Yeah. NASA developed the shuttle for the Gemini program's budget. That's why the shuttle had so many problems, Blood Fam, because they basically got it to like version 0.75 and then called it a day. Because they had to. NASA had no choice. Because they were under pressure to get things done. There's a jobs program for being honest. Absolute marvel of human ingenuity and probably my favorite spacecraft, but come on, it wasn't designed to be reusable the way we speak of reusability today. Please hold. Okay, check this out. I'm on the wiki page for the list of space shuttle missions. Okay? List of space shuttle missions. So, hear me out, dude. I understand what you're saying. And first of all, like, dude, Blood Fam, it's a slippery slope with the jobs program thing. Because if you say the shuttle's a jobs program, that means you got to say the Apollo program is a jobs program too. I don't mind if there's jobs programs. I don't mind NASA being around. I think NASA's a good thing. There's plenty of awesome things that have come out of NASA funding, right? If Uncle Sam wants to spend money, I don't have a problem with them spending money like this. That's fine with me, right? Now, with that being said, because they basically shorted NASA. Uncle Sam shorted NASA when they decided to make the space shuttle, the same way that somebody would short a stock. Literally GameStop minus, diamond hands, right? So the shuttle first flew in 1981. Check this out. This is a list of space shuttle missions, right? So they had the approach and landing tests in 1977. First launch. Okay, how many launches were in 1981? 2. STS-1 and STS-2 with a reused spacecraft. Okay. Let's look at 1982. STS-3, STS-4, STS-5. Okay. That's 3 shuttle launches a year. And now Blood Fam, I want to be very clear. This is where we ended up at the end of the shuttle program. 3 to 4 launches a year to the space station. Okay. Let's go to 1983. STS-6, STS-7, STS-8, STS-9, and then they changed the naming convention to reflect federal funding. That's why it's STS-41B. So how many in 1983? 1, 2, 3, 4, right? Okay. So you got 4 launches. Like I said, that's where we ended up. Let's look at 1984. 1, 2, 3, 4, 5. 5 launches. Better. Let's look at 1985 now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 launches. That's almost 1 launch a month. And the shuttle program was still ramping up. What they were aiming for is 2 launches a month. And guess what? If you look at 1986, we all know what happened in 1986, which sucks. It's terrible. A shuttle mission had already flown in January of 1986. They were aiming for 2 shuttle missions a year, so 24 shuttle launches a year, which is right on par with Falcon 9. And they were going to do it, had some dingbat just waited another freaking day to launch the stupid rocket. Long story short, NASA developed that damn shuttle for the Gemini program's budget, and it almost achieved what it was supposed to achieve, which is pretty damn impressive if you ask me. But here's the real question. Was Challenger reusable? I'm going to oh, you're a real piece of trash, man. Damn. Damn! Oh! Oh, that stings a little. You're going to hell, man. Jesus Christ. Oof. I felt that, man. Jeez. But see what I'm talking about, dude? NASA almost did it. They almost freaking did it. They were this close. And some bureaucratic freaking moron said launch it one day before. If they just waited till January 29th, they achieved their 24 flights a year, and the shuttle turns into this ridiculous vehicle that we could just fly into space willy-nilly. We were that freaking close, man. We were this close. Oh, it hurts so bad. You freaking pieces of Anyway, so after Challenger, Blood Fam, they tried to make the shuttle safer, and that part of it being safer was literally taking the thing apart every time before you fly it again. Literally taking the entire shuttle apart, taking the engines out, completely rebuilding the engines, and putting them back together, because the safest way to ensure that those engines work is to take them apart and rebuild them every time. And guess what happened? Cost of operation went... Pfft. Who would win, a multi-billion-dollar project or some icicles? Oh, jeez. There's a special place in hell for you, man. Damn. Blood Fam and I are just kidding around for what it's worth. Dark humor is a coping mechanism. I understand. Dude, you should have seen the stuff that they had planned with that damn thing. It would have been insane. It would have been insane. It would even make Starship look weird. Like, what Starship wants to do is cool. The shuttle was going to build cities on orbit. Like, cities. It's going to be insane. Yeah, I know you're kidding, bro. It's all good. I'm telling the rest of chat who think you're just like... I'm telling the rest of chat who's going, who the hell is this guy? You know? Wait, why would it be a long tangent to explain what waiting a day would have done there? I'm not sure. Why would it be a long tangent to explain what waiting a day would have done there? Oh, did I say that? If they just waited another... Okay, so... What I mean when I say that if they just waited another day is, so the shuttle has launch constraint violations, just like any other rocket. We saw Falcon 9 blowing around in the wind today. And you got to remember, and X, I know you know all this, you got to remember that the shuttle is a brick. It doesn't fly very well. It's designed to fly at Mach 25, not Mach 1. It doesn't fly very well at Mach 1. It flies even worse subsonic. It flies just good enough to be able to land, and that's about it. Now you're launching that into space. Accelerating that out of the atmosphere is a very difficult thing to do. So the shuttle had wind constraints violations, because it turns out when you try to launch something into space that has the aerodynamics of a frigging steam engine, you run into some load problems, right? It was too windy to launch that day. Also, the shuttle was using it used hydrogen its entire career for the three main engines. Hydrogen gets really freaking cold. So if the ambient temperature is too cold, the hydrogen that you would normally flow on a warm day froze over, and it caused ice all over the place. And it caused that cold temperature coupled with the ice and everything caused one of the O-rings to fail in the SRBs. Now, here's the thing. With Challenger, I won't show the footage. I can't show it on stream. I literally get sick to my stomach every time I watch it. It's very annoying to watch. The engineering unfolded is ridiculous. I mean, and then there's also 7 people getting killed. I won't profit off of death. I have a really big problem with that. So I'm not showing it on stream. If you guys want to go look it up and do it on your own time. So they had a launch constraint violation. It was too cold. So they violated one launch constraint violation by launching the stupid thing, which had been an okay thing to do in the past. They had launched in the cold before, and nothing bad happened with the SRBs. That right there is the most idiotic thing you can do with spaceflight. Oh, this system is not doing what I want it to do. That's fine. Just keep going. That's like having a wheel fall off your car and being like, I'll be able to handle if there's a deer in the road. It's fine. Let's just keep driving. I would know. I've had a wheel fall off the car when I've been driving down the road. It's not fun. First thing you should do is stop what you're doing because the wheel fell off. Right, now with the shuttle, you can't do that because no abort, right? So, okay. We have one launch constraint violation, but it was fine the last time, so it'll be okay. The second one is upper level winds. Remember the shuttle is brick shaped? It's really not very aerodynamic. It's about as aerodynamic as a skyscraper. Okay? The upper level winds were way too high for that day. So there wasn't just one launch constraint violation. There was 2. There's 2 launch constraint violations. Okay? So not only did they decide, the O-rings are known to not perform well in cold temperatures. Launch it anyway because it was fine last time. They said somebody made that decision to launch and said, the launch constraint we have a launch constraint violation and we know that it's going to be okay, but we've never launched an SRB in the cold while it's windy. All right, so now we're introducing a new thing. You know when you introduce new stimuli, that like in aerospace engineering, when you do that during testing. Because you shouldn't be failing during operational missions. All right? So, this SRB, O-ring failed, Challenger launched, hit with a wind gust, broke the SRB in half, cracked it like an egg, and that was the end of that. When I say if they'd just waited an extra freaking day, maybe it would have been too cold, and they would have launched, but it wouldn't have been too windy. Or maybe it would have been a good temperature. And maybe it would have been, maybe if it was a little too windy, they could have launched it anyway, and it wouldn't crack the SRB like a freaking egg. That's why it's so freaking annoying. NASA went freaking boats against the current here. Shortchanged on funding, way behind schedule because they were underfunded and underperforming, and they still made a reusable launch vehicle. They still made a reusable launch vehicle that was a good design. It still worked. Like I said, that's like someone asking you, "Hey, I want you to build me a Ferrari. Here's 50 G's." Well, I can't build a Ferrari because Ferraris cost 350 G's. Oh yeah, here's 50. Just do it anyway. And then basically making something that's almost as good as a real Ferrari, and then the wheel falls off. And then you got to stop because the wheel fell off. Yeah, see? How's that for bringing analogies back in, huh? Pretty good, huh? It's called a variable. In engineering, and part of Challenger's engineering ethics, and part of the engineering ethics lessons learned from Challenger, which comes from the Rogers Commission, which Neil Armstrong was on. He was on the accident investigation board for Challenger. There's a process called normalization of deviance. It basically says, I launched this thing. It did something I didn't want. Meh, it's fine. Whatever. Is your view benefiting from hindsight, but you are sure they could have made the decision that day? Yes. No, Foz. It's not benefiting from hindsight. I'm literally telling you what the Rogers Commission said. And now the Rogers Commission was in hindsight. But, look, I'm not trying to personify the engineering, okay? But the vehicle will be telling you something. It tells you something. Just how an old car, if you know what to listen for, it's telling you something. Like, hey, I'm not getting enough fuel, or hey, I have no spark, or hey, you didn't pack a wheel bearing correctly, and now one of the wheels is going to fall off. There are signs. There are things that you should be recognizing. The space shuttle literally told them as best as it could that it can't launch in the frigging cold. It can't do it. The O-rings had failed on past SRB flights. 4 or 5 times they launched in the cold, too many times. And they were playing Russian roulette at that point. They launched, 41C had an O-ring problem, 41D it was called SRB blow-by, right? This problem had manifested itself before, and what had happened is because the O-rings were failing, the superheated gases from the SRBs were basically welding the segments together. They were melting the O-rings and welding the segments together. And that was seen as, oh, it's double redundant. It's triple redundant now. It's single redundant with 1 O-ring. It's double redundant with 2 O-rings. Oh, and if the O-rings fail, it'll seal itself together. Now it's triple redundant. Ha 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 ha. That's not how you factor. And they were factoring that into their risk assessment. What are you doing? Oh my God. I'll go back to using cars as an analogy again. That's like driving down the road and having a wheel fall off and saying, oh, I'm more fuel efficient because there's less friction because only 3 wheels are touching the ground. Like, oh, wow, that's dumb. Night, Sun Temple. Did you watch Apollo 10.5? What is this, Mac? No, I haven't, but that's kind of cool. It's my opinion that some of the government slowness in NASA due to the lessons learned from Apollo 1, Apollo 13, Challenger, and Columbia. Yeah, there you go, Hokie. That's the other reason to take your time. The company that made the O-rings, Morton Thiokol, was also at fault since the rings didn't pass design requirements. Yeah, and once again, rings didn't pass design requirements, rings failed in the cold. The engineers knew that they would fail in the cold because they didn't have enough time and money to get them engineered correctly. This reeks of underfunding. It reeks of underfunding. So, like I said, that SRB blow-by had happened in the past. It happened. It was behavior that was normalized. Deviant behavior that was normalized. And once again, I'm in the confines of engineering now. I know people like throwing those terms around for other things nowadays. You do not normalize deviance with your engineering. You will quite literally get someone killed. This is not anything that we didn't know from Apollo 13, from Apollo 12 during launch. This is the lightning strike from Apollo 1. Shorted wires in an oxygen-rich environment. This is not anything we didn't know. They were factoring in triple redundancy on the O-rings because they were malfunctioning, and they were factoring in it as being safer. Like I said, read the Rogers Commission. You could read all about this. This is all public information. I'm not pulling this out of my tail. The Rogers Commission, 1986. Neil Armstrong was on it. And so was, I think Sally Ride was on it too, if I'm remembering right. Yeah, you get a cascading failure, Foz. So, like, once again, this is not something that, oh, well, you can know that from hindsight. That's actually, you asked a good question. It's not something that you learn from hindsight. The signs were there. Nobody had the wherewithal to freaking interpret it, or anybody that tried to was like, nah, screw you. Nah, screw you. You don't know what you're talking about. And that's why I get so freaked out every time nowadays when a budget releases and I see programs getting underfunded. Especially ones that have to do with people. Lunar Lander, I'm looking at you. That never leads to anything good. Every single time a project has been underfunded, it's either gotten somebody killed or it's been slowed to basically uselessness, where it's just a bunch of guys talking about how they're going to launch something and then they never do. Yeah, Bon. Well, cars are something that's easy to understand, and yes, I have had a wheel fly off of a vehicle because the hub just decided to fail. Underfunding is dangerous. You're going to get people hurt. One of the SRB engineers, a Morton Thiokol engineer, told NASA not to launch because of the new O-rings would fail, and NASA head guy at the time said, "Give us the go or lose the contract." Yeah, exactly, makers. That's what I mean, dude. Remember how we were talking? If you guys have been here for a little while, first of all, thank you for watching all this time. I do appreciate you listening to me, spew out all this information. Thank you. We were talking about how in space flight you cannot let feelings affect your judgment. That is a use case right there, or a case, well, not a use case. That is a case scenario right there of letting feelings affect your judgment, and that the direct result of that and ignoring the engineering got 7 people killed. Did anybody go to jail for murdering 7 people because they decided to make a decision based off of how they feel? No? No? Okay, cool. That's what I mean. You can't screw around with this stuff. And that very much pertains to the FAA making sure they get everything done so Starship can be safer in the long run. Because in this particular scenario, going back to Starship, we have the funding. The funding is there to make this work. Funding is there to make that work and make it work well. Let's make sure we do it right. Learn the lessons from the damn shuttle program, please. Would you say facts don't care about your feelings in this case? Demo, I don't like using Rule 8 memes about stuff with engineering because that means I'm just regurgitating what someone else has to say. You really have to think logically, and sometimes that's at odds with how you feel about things. Because, dude, look, we could sit here and lie to ourselves, but you know what doesn't lie? Physics. Physics does not lie. The laws of physics are very clear, very straightforward. There's no interpretation on anything that's working within practical Newtonian physics. There's no interpretation there. There's no laws, there's no leeway, there's no loophole, except quantum mechanics, but that's not Newtonian physics now, is it? If you're making a shuttle that's designed to work with physics, not like teleportation or anything weird like that, that's just within the practical confines of physics, you can't kid yourself. You can't tell yourself that these physics don't exist because I don't want them to. That will get someone hurt. Oh yeah. That will get somebody hurt. We got to be careful. And dude, I don't mean to go so super serious about this, but it's so freaking important. Like, oh my God. I know, it's like, wow, EJ's getting real intense here right now. I know. Trust me. I'm not, I cannot stress this enough. Damn it, X. Well, actually, teleportation would also be physics if it worked correctly. X, if I ever meet you, I'm kicking you directly in the nuts. Okay, like directly. Not my foot either. My shin is going to squash your testicles. Just like if this is you, this is my foot. Say my fingernail's my foot, like this, not like this, right? Not toe right in. No. Shin. My shin is going up in there. Okay, my shin is going up in there. You understand? All right. Anyway, let's get out of serious mode there for a second. Feelings are physics because they're created by electrical pulses. Oh, nice demo. Nice. Look, I don't know where you're trying to go with this conversation, but yeah, I could very much guarantee that it's not where I'm It's not where I'm trying to go with this conversation. I'm trying to teach practical lessons here about physics, and yeah, you're not helping me. Yeah, you're not helping. Because, you know, context is hard to understand nowadays. Just use a vice grip. Slowly. Oh. Physics didn't have anything to do with the 737 MAX. That was crap software and no education. So it didn't fly through the air and crash and kill people, or? Am I supposed to be helping? Yeah. Okay. All right. That's enough. Let's go see what the rest of the Starship video is. Don't put a kappa in retrospect demo to try and give yourself an out for not looking like an idiot in chat. You just made a fool of yourself. Own it. Joke's on them. I was just pretending. Okay. All right, so once again, this is the NASA spaceflight footage. This is the update at Boca Chica for what's going on here. Hey, Celtic, what's going on? Ooh, new Starship quick disconnect. Hey, yeah, baby. All right, let's see. What do we got here? So there's your LOX line right there. Are those frowny faces? Yep. Okay. Are those frowny faces? Yeah, okay. So that's a smiley face right there. This is the tape to make sure that's basically duct tape. It's not exactly duct tape. It's I think it's like aluminum tape or something. But it's covering up the umbilicals here, and they draw faces on them. Yeah, that's what happens. So it's interesting here because we were talking about the IDSS a little while ago, the docking system standard. Ice Mage had a question about that. Look, it's interesting because the quick disconnect has hooks on it. It has hooks on it that are similar to a docking port mechanism for spacecraft to spacecraft up in space. Now, I don't think I need to tell you why SpaceX would want their umbilicals to be able to dock automatically. One reason, first and foremost, is that, well, they need to automatically stack Starship and automatically connect the docking ports. How carrier umbilical plates for rockets that ferry commodities into the vehicles, basically the gas pump for a rocket, how they usually work is that they install them first by hand. Like on SLS, it's done by hand. They move it into position, they line it up, and they bolt it down with explosive bolts, right? But SpaceX doesn't want to use explosive bolts because that takes time. They want to launch a lot. So they have a quick disconnect arm that is literally designed to dock and undock quickly. It's almost like it's in the name. To the vehicle, which is interesting. You got 4 latching hooks right here. You got your LOX line and your methane line right there. These are gas recirculators, and that's probably helium or nitrogen. I've seen diagrams of this. I just don't know what it is. There's like electrical power and stuff like that. And then see, it's got 4 trailer hitches right here to help locate it on the umbilical for Starship. These are guides right here. See them? They look like a trailer hitch. Play the video, it zooms out. And then see those 2 up at the top? Cameras. And then there's one on the side too. Those are cameras to align the thing. Damn, that thing is cool. Look at that steel braided line. Steel braided line, steel braided insulated line. Anybody know anything about hardware? How much do you think that line costs? That's, it's a Canadarm with pipes. Changed my mind. Kind of, yeah. At least $350. Yeah, that steel braided line is expensive, especially like 30 feet of it. You've got to ask, you can't afford it, indeed. $1 million. 20 bucks, take it or leave it. Can you get that on McMaster Car? Probably. I have it on, Xeon, I have it on first-hand authority that people at SpaceX raid McMaster Car on the daily. Yeah, I have that on first-hand authority, which is really funny. From multiple people that work at SpaceX. They're like, oh, I'm on McMaster Car all the time. Oh, yeah. Which I think, that's hilarious. I think that's really funny. I have that on first-hand authority from multiple people, dude. Yeah, look at that thing. Crazy. I'm still trying to figure out what these things are for up here. See these things, the X part? I'm still trying to figure out what those things are for. Now, obviously, there's a bracket there to mount the optical cameras, right? Those are the cameras probably so the system can see what it's trying to dock to, right? Hey, I first showed you McMaster Car, claiming it. Yeah, you did. Yeah, you did. You'll like the last link. Oh, the latching in defector. Yeah, it's pretty cool. Isn't that weird, Smarks? That zzz, zzz, right? I tried to make that in KSP once. It almost worked. We almost got it right. We just don't have cable. Trash bags, Sebi, to insulate the lines. Yeah, they use black trash bags. Yep. Alignment? Yeah. Ferd. Mac, I'm gonna try. Wait, what are my values? Truck. Maybe it turns automatically into Starship via rollers on the outside. Yeah, maybe. Oh, there it goes. Umbilical being hoisted onto the platform, or the Matrix and a Squiddy being recycled. I'll let you decide. Sentinels. Killing machine designed for one thing. Search and destroy. Tank. Tank, charge the EMP. EMP? Electromagnetic pulse. It's our only defense against them. Isn't that two things? Shh! Yeah, I'd like to remind you that this thing with the hoses attached to it is the size of a semi-truck trailer. And yeah, somebody already said it in chat. Compared to everything else, it looks very, very tiny. Yeah, exactly, Smirks. Yep, you're reading my mind there, dude. There's the tagline right there. They're gonna get it over where they need it, and somebody's gonna grab that white string on the end and pull it in. Like reeling in a fish. Also, once again, honk honk. I will never fail to convey scale. Look at the guys walking around on that quick disconnect arm up there. Should tell you how big this thing is. Yeah, it's see, this is small. This is a small guy. Look, this is so small. Alright, watch, they're going to grab the taglines. They grabbed one, now the guy's going to grab the other. There we go. They got both the taglines, and now the guys are going to use the taglines, those little pieces of string, to flip it around. See? Yeah. Sure, Penta. Yep, you're gonna hook those umbilicals up. Probably do that while it's hanging. It's probably easier to do it that way. Oh, that's so cool. This is a traveling monument to steel workers and stuff. That's actually really cool. That's really freaking cool. I'm gonna go over here. Look at that thing. And now they moved it over here. I'm gonna go back over there. Ready? That is a nice crane. Jeez. Look at this. Dude. You gotta be kidding me. Hey, wait a minute. Hey, wait a minute. The paper says one gorilla. One gorilla, two gorilla. Beside, look, they're in love. If somebody gets that reference, you get points. No, seriously. What's this guy got up there, fellas? Do we know what's that thing? This cart thingamajigger. The tractor thing that it's not a tractor, but yes, Galactic, thank you very much. Hey, wait a minute. Floor waxer? Concrete buffer? A buffing machine. What are they buffing up there? Did we ever see a pump truck pump concrete up there? Did we miss that? They're dropping chalk for the ball field up there. That's the best answer I've heard, Atago. Yeah. Yeah, that looks like a concrete buffer to get the air bubbles out of freshly poured concrete, which means that there's a huge concrete slab on top of this thing. If that is what I think it is. What else would... Okay, so chat, let's entertain this idea. If there wasn't concrete up there, what other tool could that be? Helicopter landing pad? That would be cool. Could be a grinder. That is like a floor waxer, but with sandpaper on the bottom. I used to use those on floors. Polisher, glass polisher. Yeah, but if that was like a floor polisher or something, why would he be polishing the floor if there's no ceiling? Honest question. Like, I'm actually asking. That's not a rhetorical question. Would you polish the floor at this stage in building? I don't know. Smirks, I believe that. It's a vacuum cleaner. It's a lawnmower. Okay. What is that? No wrong answers. It's a lawnmower. Ah, yes. I'm just mowing my lawn 250 feet up in the air. Sure. Plate compactor. Okay. Roughing the floor so you can glue floor tiles. Interesting. I was going to say, I don't ever remember them moving concrete up there. Oh. That does look like a steel floor that you'd use for concrete, though. See how it's corrugated? If you have if you need a concrete slab up on a building somewhere for whatever engineering reason, you'd use corrugated floor like that. The reason why you'd use corrugated floor is because concrete adheres better to corrugated floor because it's more surface area. That's more surface to adhere to. So if you have a flat floor, right? Say that's a certain amount of area, but if your floor goes up like this, that's more surface area to adhere to. So that is the type of floor that you would pour concrete onto if you needed concrete at the top of the dang building. Yeah, maybe, Bon. I'm not sure. Yeah, Creeper. Mm-hmm. Yeah, see? Corrugated floor. It's also a possibility that they lifted a little concrete mixer up there already, and we just can't see it. And they don't have like a pumper truck up there, so they have to mix it up, well, on site. You agree with Bon? It's a sander for waterproof membrane preparation. For the metal, though, guys, waterproof. This isn't the roof. The roof is up here. That's not the roof. That's a floor. Remember that. I mean, once again, I could be wrong. I'm not sure. Yeah, corrugated is stronger, so it can take the weight, Mycon. Exactly. You wouldn't use that type of flooring if you weren't going to put concrete up there. But then again, I don't know enough about industrial architecture to be able to tell you exactly what it is. That's where all the hardware is going, generators, etc. Yeah, maybe. Yeah, Booster 7. See, the other building has, at the very top, it has... There's a bar over here, and I'm not sure what's on that side. And then you can use this door to get from one side to the other. Guys, don't worry, fellas. That's only 150 feet off the ground. Yeah, it's no problem. Hey, Joe. What's going on, brother? How you doing? No, Kuro. No, it wasn't. No, it doesn't look like that. So, if you look at the... so, this is High Bay 1. The High Bay is High Bay 1. The Wide Bay is High Bay 2. High Bay 1 has a crane. You can see it right there with the flag on it that goes this way. It goes front to back of the building, right? High Bay 2 has 2 gantry cranes that go left to right. They go this way, not this way. They go that way. And then that structure that with the corrugated floor is on top of all that, because the crane tracks go all the way across and back. You can see that they put an elevator shaft in right there. Just on a side note. How's the truck coming along? 250 runs and drives, dude. I fixed the ignition and everything. Still got to put the second tank in. Got to do some work with the bed. And then just once over the whole thing, and then she's good to go. Probably going to work on it this weekend, though. I should put a hotel up there. Jim, I was thinking that the offices, engineering offices, would be up at the top. Or mission control. That would be a good place to put mission control at the top. Burp. I haven't bought any exhaust for the 250 yet. Yeah. Or the 100. Either truck. I have to do that. But it's like, I'm in a hard, between a rock and a hard place here. Because, I want to finish the exhausts on all the trucks, right? So they can, you know, truck. But I also want to save money because house. But if I save money, so if I save money for a house first, I can buy garage, and then I finish truck. Or I could finish trucks now, and then have garage and work on other things. Yeah, that's the right move. We should buy the exhaust now. Sorry, sorry, just quick tangent. Yep, about my personal finances. That's good. Yeah, Rizik, maybe. That's what they have to do at Hawthorne. All the engineering offices are directly over the assembly line. Well, production line for Starship. Buy a warehouse to fit many trucks. I'm probably going to need to make at least 4 times what I make now if I wanted to do that for a reasonable price around here. Ah. Your title. Oh. Thank you. That's Space News. This is the Space News. Nah, my title, the title got all screwed up today, Toronto, because Rocket Lab was like, yeah, we're launching today. Wait, never mind. We're just gonna launch on your day off, EJ. I'm like, oh, thanks, guys. They're like, yeah, you're welcome. We'll see you then. I'm like. Four times, you say? Hey, Chad, did you know that you can subscribe for Twitch Prime once a month for free? You guys had a tip train yesterday. You don't owe me nothing. Now it's Space News. Yeah, Space News started right now. Turk. Yeah, dome parts
Discovery,
right there.
go at throttle up.
Rizik. Woo! 12-month resub. Thanks, man. Right, meow. Are you saying meow? Am I saying meow? Oh, that...
Discovery, go at throttle up.
Pokey gifted 5, Gaw gifted 5, and Predominant gifted 20. Oh. Well, that's nice. Thank you. Look at the Lego face up there. How dare you say you owe me nothing? I'm not saying anything else about it, because the more I talk about it, the more... Oh, oops. Thanks for the bits, Membo.
Discovery, go
6
and throttle.
subs per minute. Thank you, Kyron. Merci. Oh, for frick's sake. Look at the Lego. Chat, no, jingle. Look at the keys. Look at the Lego head. Sebi, thank you very much. Dankeschön, mein friend.
Discovery,
Oh.
go and throttle up.
Oh, great. So puns. Thanks, Geeson. I appreciate it, man. That's 10 from Geeson, 1 from Sebi, 6 from Kyron. You guys, once again, you're too good to me. You're too good to me. Yeah, Vaughn. No. They really took the time to put a Lego head up there. No, Sup, I haven't done it yet. Now I have to. I'll do it. We'll do it over the weekend, man. I'll add it to my reminders right now. Pause. Hang on. I gotta do that.
Discovery, go
Okay.
and throttle up.
I added it to my reminder. Oh, jeez. 6 subs per second. 6 tons per second.
Discovery, go and throttle up.
Thanks, Sup. I appreciate it. Anyway, what was the last bit of footage there while I was giving myself a reminder? Now, they brought another Raptor 2 in. See that? That box right there. That's something that I've noticed with these Raptor 2s. See that? That's the, a pilot would call that the FADEC. That's basically the ECU for the engine. They've really, really consolidated that down. Compare that to the Christmas tree that was the early development Raptors. It looked like a freaking like angel hair pasta up in here. I don't know if I can race today, but I will try. All right, man. No problem. The SpaceX probably has another name for it, but yeah. Yeah, see it right there? You can tell it has to do with electronics because it's got a lot of wires going to it. It's pretty neat. Last week's injury is still hurting. What did you do? Wait, what? Wait, you didn't tell me about this. How much weight was reduced on the Raptor? Oh, I don't know. I don't know. Girl, they're still heavy. They're still heavy. You can tell because they need a big forklift to pick the thing up. So it's still pretty dang heavy, but... Yeah, .com, that's right. Damn flanges. My hand got sliced up while racing last week from the paddle shift after a force feedback thing. Oh, geez, man. I'm sorry. I hope you're okay. All right. Anyway, guys, it's about 8 o'clock. I think I'll get in and do some racing practice. We got an hour endurance race at Spa today with LMP cars for Friday night racing. So I think that's gonna do it. Unless I missed anything, I think I got most of it. I think we've got most of the space. There's a lot of good talks today. So yeah, Spa-Francorchamps is a track in Belgium. It's literally like a roller coaster. If a roller coaster was a racetrack, so should be in for some good racing. My goal is to literally finish. Yep, and not crash. Oh, you want to race your car better? Have you tried not crashing? Liam, we could do that tomorrow for Space News if you want, buddy. There's going to be plenty more tests. You guys, with that McGregor cam, Liam, you're going to see how much SpaceX does testing, guys. They're firing Raptor off multiple times a day. That's how they were able to go so fast. That's why the Merlin engine got so dang reliable so quickly. They just kept firing. Just keep firing it. Just keep doing it. Keep firing. Keep firing! Elons? Combination to the Raptor to start the Raptor is 1, 2, 3, 4, 5. That's amazing. I got the same combination on my luggage. Clearly crashing didn't stop Nikita from success. That, I mean, Rizek, you know what the thing is? You know what the thing about him, Stroll, like all those guys, the pay drivers, is that they're not bad drivers. They're just not developed there. They're not developed yet. You have to, you know, that these drivers like Mazepin, you know, Stroll has gotten better. Guy doesn't check his mirrors. It's pretty obvious sometimes, but don't get me wrong. I couldn't do any better. But you know, these guys, you know, win Formula 3 and then they pay for a seat in Formula 1. You skip Formula 2. That's like trying to learn U.S. history and skipping the Civil War. You know what I mean? Even if you ace the rest of it, you still don't understand the context of our country's history because that was such a pivotal point. You know, these drivers have skill. Mazepin wasn't a bad driver. He wasn't that bad. He did very good in Formula 3, and so did Stroll. They both did. But they weren't ready for Formula 1. Formula 1 is a different beast. Formula 3 skills don't really translate too well. You need to go through Formula 2, and you need to steadily progress to becoming an F1 driver if you can handle it. And with that being said, if you can handle it. Latifi's still at the back. I don't know what's going on with him, Shaw, but whatever. Yeah, with Mazepin it was Formula 2. Even dude, some guys spend a couple of years in Formula 2. They spend a couple of they spend a couple of years there to develop. That happens. That's how you should do it. You know, you gotta develop those skills. And if you don't develop those skills and you skip or you move to Formula 1 prematurely, like it's screwing them. You're shooting yourself in the foot doing that. I mean, people, of course, you're going to jump at the chance for an F1 seat, but you know, it's very rare that you get a second chance in Formula 1. Look at Ocon, for instance. When Esteban Ocon made it to Formula 1, he was a dick. He was a dick, and he just crashed people off the road, and he yelled at them, screw you, screw you, screw you. He wasn't ready. He wasn't ready, so they put him on the bench. And now, the second time around, he's ready. Do you hear him whine about stuff? You ever see him run people off the road? No, not really. He's a much more talented driver this time around. It's really easy to spot. Steiner said that Mazepin just didn't want to take any advice, and he was pissing everybody off at the team. Yeah, Sevi, I mean, it sounds like there's a little bit of entitlement going on there, but then again, I'm probably not the guy that you want to talk to about, you know, understanding what goes on in Russia. I thought I was, but yeah, no, I got that wrong.